Welcome, traveller of the mind. Settle yourself now. Let your body sink into the surface beneath you, feeling the gentle pull of gravity not as a weight, but as an embrace. It is the earth itself reaching up to hold you, cradling you against the vast, quiet backdrop of the universe. Close your eyes. Let the room around you dissolve into a soft, velvety darkness, a comfortable void where the only thing that matters is the rhythm of your own breathing. In and out, slow, deep, steady. Imagine, if you will, that you're floating in a safe, warm space suspended in the starlight. You're weightless here, untethered from the worries of the day, disconnected from the ticking of the clock. There is no time here. There are no deadlines. There is only the ancient, comforting hum of existence. As you drift, allow your shoulders to drop, allow your jaw to loosen, and let a wave of relaxation wash over you, starting from the crown of your head and flowing down, down, down to the tips of your toes. You are safe, you are at peace, and you are ready to listen to the whisper of the world. Tonight we embark on a journey not across the stars, but deep within the ground beneath us. We're going to explore the story of the Earth, a story written in stone, in heat, in pressure, and in time. It is a slow story, a story that takes millions of years to turn a single page. There is a profound comfort in geology, in the knowledge that the ground we walk upon is solid, ancient and enduring. It puts our fleeting moments into perspective, wrapping us in the blanket of deep time. So let go of the surface world. Let go of the noise. Picture yourself lying on a bed of soft moss in an ancient forest, or perhaps floating on a calm moonlit lake. The air is cool and fresh. The silence is heavy and sweet. Let us begin our descent into the dream of the stone. To understand the ground that supports you, we must first cast our minds back, drifting in reverse through the corridors of time. Imagine a clock slowing down, the second hand sweeping slower and slower until it stops, and then begins to unwind. We travel back past the history of humanity, past the reign of the great reptiles, past the first forests, until we reach a point 4.5 billion years ago. This is the birth of the planet. Visualize the vast, silent darkness of the early solar system. It is not empty, but filled with a swirling, majestic cloud of dust and gas, glowing with the faint, ethereal light of newborn stars. There is a sense of cosmic gathering here. Picture these tiny particles of dust, cold and ancient, beginning to dance with one another. Gravity, gentle as a whisper, pulls them together. Pebble joins pebble, rock joins rock. There is no rush in this process. It is a slow, celestial accumulation. Over millions of years, these fragments coalesce, gathering mass, drawing in more material, heating up from the sheer energy of their reunion. It is a chaotic, beautiful ballet of matter forming the sphere that will become our home. Think of the heat generated in those early days. The young Earth was a molten ball, glowing like an ember in the hearth of the night sky. It was a world of fire and potential, fluid and shifting. Slowly, very slowly, the surface began to cool. The angry red turned to a dark, solid crust sealing in the heat, creating a skin over the heart of the world. This immense age, this 4.5 billion years of history, means that every stone you touch, every grain of sand you see, carries within it the memory of that stardust origin. You are resting on a foundation that has weathered eons, a testament to endurance and survival. As we drift deeper into this vision, imagine your consciousness sinking through that cool outer crust, moving down through the miles of rock, descending towards the very centre of the planet. Here, miles beneath the surface, lies the inner sanctum of the Earth, the core. Picture a sphere, shining with an intensity brighter than the sun, yet buried in the profound dark of the deep Earth. This is the planet's heart. It is composed mostly of iron and nickel, metals that are heavy, dense, and strong. The core is divided into two distinct realms, a relationship of movement and stillness. The inner core is a solid ball of metal suspended in the centre of it all. Despite the unimaginable heat, hotter than the surface of the sun, the pressure here is so immense, so crushing, that the iron cannot melt. It remains solid, a dense anchor keeping the planet steady in its rotation. It is the ultimate symbol of stability, a solid point around which everything else turns. Surrounding this solid centre is the outer core, a vast ocean of molten metal. Visualize this layer as a sea of liquid iron, swirling and flowing in slow, hypnotic currents. These currents are not like the frantic waves of a surface ocean. They are thick, viscous, and deep. As this molten metal flows around the solid inner heart, it creates a magnetic field that reaches out into space. Imagine this field as an invisible, protective bubble surrounding the Earth, shielding us from the solar wind, creating the dancing northern lights. The core is not just a hot rock, it is a dynamo, a silent engine humming in the deep, protecting the fragile life miles above. From the intense heat of the core, we let our awareness rise slowly, drifting upward like a bubble in honey, until we reach the layers closer to the surface. Here, we encounter the great puzzle of the world, the tectonic plates. Imagine the surface of the Earth not as a single, unbroken shell, but as a mosaic of cracked eggshells, giant rafts of rock floating on the softer, hotter mantle below. These are the continents and the ocean floors, and they are constantly on the move. This movement is the definition of patience. It happens at the speed that fingernails grow, a mere few centimetres a year. If you were to sit and watch a continent move, you would see nothing. It is a motion so slow it feels like stillness. Yet, over the span of millions of years, this drift changes the face of the world. Picture the globe as it was hundreds of millions of years ago, when all the land masses were huddled together in one great supercontinent called Pangaea. It was a vast embrace of land surrounded by a single endless ocean. Visualize these massive plates drifting apart, carrying forests and mountains with them, opening up new oceans, closing old seaways. It is a slow, majestic dance of stone. When two plates meet, they do not crash with the speed of cars, but with the irresistible force of deep time. They buckle and fold, or one slides quietly beneath the other, returning to the mantle to be melted down and recycled. This constant, creeping motion reminds us that nothing is truly static. The ground beneath you is on a journey, carrying you slowly, imperceptibly, to a new destination in the distant future. What drives this colossal movement of continents? We must look to the fluid that lies beneath the plates. Imagine a substance that is both rock and liquid, a glowing orange-red syrup of the Earth. This is magma. When it is deep underground, hidden from the sky, we call it magma. It gathers in vast chambers, pockets of heat and potential, waiting in the silence of the crust. Picture a magma chamber as a subterranean cathedral of fire. The walls are made of solid rock, but within, the substance is thick and roiling. It glows with radiant heat, illuminating the darkness of the underground. Crystals float within this melt, forming slowly as the magma cools in the corners of the chamber. It is a place of creation, where the raw ingredients of the earth are mixed and melted. Sometimes this magma finds a path to the surface. It pushes through cracks, seeking the release of pressure. When it breaks through the crust and spills out onto the land or into the sea, it is given a new name: lava. Visualize a river of lava flowing down the side of a volcano at night. It is mesmerizing, a bright ribbon of gold and scarlet against the black rock. As it flows, it begins to cool, the surface turning to a silvery grey skin while the red heat continues to pulse beneath. It creates new land, adding to the island or the mountain, a reminder that the earth is still growing, still building itself, layer by molten layer. When this molten rock, whether it is magma deep underground or lava on the surface, finally loses its heat, it transforms. It freezes into solidity, becoming what we call igneous rock. The word igneous comes from the Latin word for fire. These are the rocks born of flame. Imagine the cooling process. If the magma cools slowly, deep underground over thousands of years, it has time to organize itself. The minerals within it grow large and distinct. Think of a piece of granite, the speckled stone often found in mountains or perhaps on a kitchen countertop. Look closely at it in your mind's eye. See the interlocking grains, the pink feldspar, the clear quartz, the black mica. They fit together perfectly, a jigsaw puzzle with no gaps. This texture tells a story of a slow, peaceful cooling, wrapped in the warmth of the earth. The crystals had time to grow, to find their place. Now, contrast this with lava that erupts and meets the cold air or the freezing ocean. It cools instantly in a matter of seconds or minutes. It has no time to grow crystals. It becomes basalt, a dark, fine-grained rock, smooth and sometimes black as night. Or if it cools even faster, it becomes obsidian, natural glass. Picture a piece of obsidian, sharp and shiny, reflecting the light like a dark mirror. These igneous rocks are the foundation, the primary crust of our planet, the frozen echo of the Earth's fiery beginnings. But not all rocks are born of fire. Some are born of water, wind, and time. As we move from the volcanic landscapes, let us drift to a quiet coastline or a calm riverbed to witness the birth of sedimentary rock. This is a gentle process, a settling of dust. Imagine standing on a beach. The waves roll in, carrying sand, silt, and tiny fragments of shells. As the water recedes, it leaves a fine layer behind. Over years, centuries, and millennia, these layers build up, one atop the other. The weight of the new layers presses down on the old, squeezing out the water, compacting the grains. It is like the pages of a great history book being glued together. Visualize a cliff face by the sea, striped with bands of different colours: red sandstone, grey shale, white limestone. Each band represents a different era, a different environment that once existed. Held within these layers are the secrets of the past. Fossils. Imagine a leaf falling into a muddy lake millions of years ago. It is covered by silt before it can decay. Time passes. The mud turns to stone, and the delicate impression of the leaf is preserved forever, a snapshot of a prehistoric autumn. Sedimentary rocks are the memory keepers of the planet. They tell us where ancient rivers flowed, where deserts once stretched, and where oceans once covered the land. They are the result of stillness, of particles coming to rest and being held in the embrace of the earth. There is a third path for stone, a path of transformation. Deep within the earth, rocks can be changed without melting. This is the realm of metamorphic rock. The word means change of form. Imagine a rock, perhaps a simple piece of limestone buried deep beneath a mountain range. The weight of the mountains above creates immense pressure. The heat from the Earth's core rises up. The rock is not hot enough to turn back into magma, but it is hot enough to become soft, pliable, and reactive. The minerals inside begin to change. They recrystallize, becoming denser, harder, more beautiful. The limestone transforms into marble. Visualize a block of white marble, smooth and cool to the touch. It seems pure and uniform, but it was once a gritty seabed. Through heat and pressure, it has been purified, the impurities swirling into delicate grey veins that dance across the white surface. Or picture a piece of slate, dark and flat. It was once soft mud, but pressure has aligned its minerals so perfectly that it can be split into thin, durable sheets. Metamorphism is the Earth's alchemy. It takes the mundane and makes it magnificent. It twists and folds the rocks, creating wavy patterns that look like frozen taffy. It is a testament to the fact that under pressure we do not break. We change, we adapt, and we become something stronger and more complex. Hidden within these rocks, often tucked away in secret pockets or veins, lies the Earth's jewellery, crystals and gemstones. These are the result of perfect order in a chaotic world. Imagine a hollow space inside a rock, a geode. On the outside, it looks like a rough, unassuming potato-shaped stone, but crack it open and you reveal a glittering cavern. Picture purple amethyst crystals growing inward, their points sharp and faceted, catching the light. These crystals formed from mineral-rich water seeping into the hollow cavity. As the water slowly evaporated or cooled, the minerals were left behind, arranging themselves in perfect geometric patterns. Molecule by molecule, they built these towers of colour. Think of the clarity of quartz, transparent and cool, like frozen water that never melts, or the deep red of a garnet, formed under the intense pressure of metamorphism. Crystals are the Earth's way of organising matter into its most efficient, stable and beautiful form. They vibrate with a sense of stillness and purity. Holding a crystal is like holding a piece of frozen time, a fragment of the Earth's hidden geometric soul. They remind us that beauty often grows in the dark, in the quiet, enclosed spaces where it is safe to develop perfection. Finally, we turn our gaze to the forces that shape the surface, the gentle sculptors of the landscape. We speak of erosion. It sounds destructive, but it is also an artist. Its primary tool is water. Visualize a clear, cold mountain stream tumbling over rocks. Pick up a stone from the riverbed in your mind. Feel how smooth it is, how round. There are no sharp edges here. The water, over thousands of years, has tumbled this stone, rubbing it against others, polishing it into a perfect, pleasing shape. This is the softness of water winning against the hardness of rock. It is the ultimate lesson in patience. The Grand Canyon, vast and breathtaking, was carved by a single river, day by day, grain by grain. Wind also plays its part. Imagine a desert landscape where the wind blows sand against a cliff, carving out arches and bridges, smoothing rough surfaces into undulating waves of stone. Erosion softens the world. It takes the jagged, angry peaks of young mountains and wears them down into the rolling green hills of ancient ranges. It returns the high places to the low places, creating soil where plants can grow. It is the cycle of renewal, the earth slowly exhaling, redistributing its weight, smoothing its own skin in a never-ending process of natural refinement. From the valleys carved by water, we look up, lifting our eyes to the highest points of the world, the mountains. These are the monuments of the Earth's power. We learned earlier of the tectonic plates moving. When two continental plates collide, the land has nowhere to go but up. Picture the slow, majestic rise of a mountain range. It is the Earth crinkling, folding like a heavy blanket pushed from both sides. The rock layers we spoke of, sedimentary, igneous, metamorphic, are thrust upward, piercing the sky. Visualize the jagged peaks of the Himalayas or the Alps, crowned with eternal snow. The air is thin and crisp up here. The silence is profound. Mountains are the bridges between the earth and the sky. They catch the clouds and birth the rivers. Despite their solid appearance, they are dynamic. They are rising millimetre by millimetre, even as gravity and erosion try to pull them down. To stand at the foot of a mountain is to feel small in the most comforting way. It reminds us of the scale of the planet. These stone giants stand guard over the world, watching the seasons change, watching civilizations rise and fall, enduring through the ages with a stoic, snowy calmness that invites us to breathe in the cool, rare air of the summit. From the high, silent vigil of the mountain peaks, where the air is thin and the world below seems like a patchwork quilt of green and brown, we turn our attention to the ice that crowns them. In the highest valleys, where the snow never fully melts, we find the great white giants known as glaciers. Imagine a river, not of running water, but of solid ice, massive and heavy, draped over the shoulders of the mountain. It is a landscape of blinding white and deep, electric blue, a blue so intense it seems to glow from within, created as the weight of the ice squeezes out every tiny bubble of air, leaving only the pure, dense crystal structure behind. These glaciers are not static sculptures. They are moving, living entities of the geological world. Picture the immense weight of the ice, pressing down with millions of tons of force. Under this pressure, the bottom layer of the glacier becomes slippery, almost fluid. Gravity pulls it, and the ice begins to slide inch by painstaking inch down the valley. As it moves, it acts as a colossal plough, tearing rocks from the mountain walls and grinding them against the bedrock below. Listen closely in the silence of your mind, and you might hear the deep, resonant groan of the ice shifting, a sound like an old wooden ship turning in the ocean, echoing through the frozen canyon. This grinding creates rock flour, a fine powder that turns the meltwater streams into a milky turquoise, painting the lakes below with colours that seem too vibrant to be real. The glacier is a patient carver, widening sharp, V-shaped river valleys into broad, majestic U-shaped troughs, leaving behind a smooth, polished path that tells the story of its passing long after the ice has melted away. As the sun touches the surface of the glacier, or as the ice reaches lower, warmer elevations, it begins to weep. Drops of water coalesce into trickles and trickles into streams, disappearing into deep, sapphire blue crevasses to run beneath the ice. This water begins a new journey, sinking away from the light of the sun, down into the hidden anatomy of the world. We follow this water as it seeps into the ground, entering the mysterious realm of groundwater and aquifers. Imagine the earth beneath your feet not as a solid, impermeable block, but as a vast, heavy sponge. The soil and the bedrock are filled with microscopic pores, tiny spaces between grains of sand and cracks in the stone. The water sinks, pulled by gravity, filtering through layers of sand and charcoal and rock. With every foot it descends, it is scrubbed, purified, stripped of the dust and debris of the surface world. It gathers in the aquifers, huge, underground reservoirs of water held within the rock itself. Picture a subterranean lake, absolute in its darkness, silent and still. This water might remain here for days, or it might remain for 10,000 years, preserved in the cool, rock-lined dark. It is a hidden treasure, a vast, clean ocean flowing in slow motion beneath the roots of the forests and the foundations of our cities. When you drink from a clear spring, you're tasting a vintage rain that fell centuries ago, a ghost of a storm that passed long before you were born, now returning to the light as a gift from the deep. Sometimes this water does more than just sit, it sculpts. In certain parts of the world, where the bedrock is made of limestone, the compressed remains of ancient sea life, the water becomes an architect. As rainwater falls through the air and soil, it picks up a tiny amount of carbon dioxide, becoming a very weak, gentle acid. It is no stronger than soda water, yet given enough time, it can carve empires in the dark. We are drifting now into the hollow spaces, the caves. Visualize the water finding a crack in the limestone. Drop by drop, year by year, it dissolves the rock, widening the crack into a fissure, the fissure into a tunnel, and the tunnel into a cavern. Float into this space. The air here is different, cool, damp, and smelling of wet stone and ancient earth. It is a constant temperature, unaffected by the scorching sun of summer or the biting frost of winter. It is a world of absolute velvety darkness, a darkness so complete it feels soft against the skin. In this silence, the only sound is the echo of water, the dripping of the architect at work. These caverns can be vast, large enough to hold cathedrals, with underground rivers rushing through them, carving sculptures out of the stone walls. It is a hidden world, a hollow earth where the geology is subtracted rather than added, created by the absence of rock, a void of mystery waiting in the eternal night beneath the hills. In these silent chambers, the water does not just take away, it also gives back. As the mineral-rich water drips from the ceiling of the cave, it leaves behind a tiny microscopic ring of calcite. Over centuries, these rings stack one upon the other, growing downward like an icicle of stone. These are the stalactites. Picture them hanging from the darkness above, glistening with moisture, tapering to a sharp point where a single drop of water always hangs, waiting to fall. When that drop finally falls and hits the floor, it splashes and deposits yet more minerals, building a mound that reaches upward. These are the stalagmites. Imagine these two stone fingers, one reaching down from the ceiling, one reaching up from the floor, slowly yearning toward each other across the void. They grow at a pace that defies human comprehension, sometimes less than an inch in 100 years. They are clocks made of stone, measuring deep time in slow rhythmic drips. Eventually, after eons of separation, the two distinct forms meet and fuse, forming a single, solid column from floor to ceiling. These formations turn the cave into a palace of alien beauty, filled with draperies of rock that look like folded velvet and flowstones that look like frozen waterfalls. It is a testament to what can be achieved with small, consistent actions repeated over vast stretches of time. Leaving the damp, cool echo of the caves, our spirit drifts upward and outward, emerging into a landscape of stark contrast. We find ourselves under a wide blue sky, bathed in the warmth of the sun, surrounded by a sea of gold. We have arrived in the desert. Here, the primary geological force is not water, but wind. Visualize the dunes, rising and falling like the waves of a slow-motion ocean. These are mountains made of loose grains, shaped by the breath of the atmosphere. Pick up a handful of sand in your mind. Feel the dry, warm grit slipping through your fingers. Each grain is a tiny crystal of quartz, a survivor of erosion that has been tumbled and blown for thousands of miles. The wind here acts as a sorting machine, carrying away the dust and leaving behind the heavier sand. As the wind blows, it pushes the sand grains up the gentle slope of a dune until they reach the crest, where they cascade down the steep slip face on the other side. In this way, the entire dune migrates, walking across the desert floor. In the profound silence of the desert, you might hear a low, humming vibration, the singing sands, caused by the friction of millions of grains sliding against each other. It is a landscape of purity and minimalism, where the geology is laid bare, stripped of vegetation, revealing the raw, beautiful geometry of the earth. From the sea of sand, we travel to the true sea, drifting from the edge of the continent and sinking into the embrace of the ocean. We descend past the sunlit shallows, past the colourful reefs, down into the crushing, quiet dark of the abyssal plains. This is the floor of the deep ocean, the most common landscape on our planet, yet one few eyes have ever seen. Imagine a vast, flat plain of mud and fine sediment, stretching out for thousands of miles in the eternal darkness. Here, the water pressure is immense, a heavy blanket that holds everything in a tight embrace. The stillness here is absolute. There are no storms, no waves, only a gentle, slow drift of currents. The ground is covered in marine snow, a ceaseless soft rain of organic debris falling from the sunlit surface miles above. It settles on the bottom, layer upon layer, creating a thick, soft ooze that blankets the rocky crust of the ocean floor. This sediment accumulates at a rate of perhaps a centimetre every 1,000 years. It is the dust of the ocean, a record of the life above, settling into a slumber that will last for millions of years. In this cold, high-pressure environment, time seems to stop. It is a place of rest, where the frantic energy of the surface world is finally absorbed and quieted by the deep. Within this marine environment, biology and geology blur their lines. In the sunlit waters above, or in shallow tropical lagoons of the past, tiny life forms work to build stone. Consider the creation of chalk and limestone. Visualize billions of microscopic plankton, tiny creatures with shells made of calcium carbonate, floating in a prehistoric sea. As they live and die, their tiny shells rain down like a white blizzard, settling on the sea floor. Over millions of years, this accumulation of microscopic armour creates thick white beds of soft rock. Imagine the white cliffs of Dover, or the soft limestone often used to build ancient pyramids and cathedrals. This rock is made entirely of ghosts. It is biogenic, born of life. When you touch a piece of chalk, you're touching the remains of an ancient ocean ecosystem, compacted by time. It feels dry and powdery, leaving a white smudge on your skin. This connects us deeply to the past. The very ground we walk on in many parts of the world is a graveyard of the sea, lifted up by tectonic forces to become dry land. It is a reminder that the Earth is not just rock. It is a collaborative project between the planet and the life it harbours. Sometimes, the preservation of life takes a more direct crystalline form. Let us transport our minds to an ancient forest, one that stood tall 200 million years ago. A volcanic eruption buries this forest in a thick blanket of wet ash, sealing the trees away from the air, protecting them from rot and decay. This is the beginning of petrified wood. Under the ground, groundwater rich in silica, dissolved quartz, begins to seep into the buried logs. It flows into the cells of the wood, filling them up one by one. The organic wood slowly dissolves and is replaced, molecule for molecule, by stone. The structure of the bark, the rings of the tree, even the damage from ancient insects, is perfectly preserved in agate, jasper and opal. Visualize a log that looks like weathered wood, but when you touch it, it is cold, hard and heavy as granite. It gleams with reds, yellows and deep browns. It is a forest turned to glass and stone, a literal freeze frame of biology. These stone trees are monuments to the idea that nothing is truly lost, only translated into a new, more durable language. We speak of colours, the red of the agate, the yellow of the jasper, and we must ask where the colours of the earth come from. Often, it is the simple act of the earth breathing. This is the process of oxidation and chemical weathering. Many rocks contain iron, the metal of blood and strength. When this iron is exposed to the oxygen in the air and the moisture of the rain, it reacts, it rusts. Picture the majestic red rocks of the American Southwest, or the rich ochre soil of a tropical island. That vibrant, warm red is essentially geological rust. It is the result of the rock interacting with the atmosphere over millions of years. This process is a slow burning, a chemical fire that gives the landscape its warm hues. Imagine a cliff face glowing in the sunset, the red stone amplifying the orange light of the sun. It feels warm to the look, radiating a sense of heat and energy. This rusting breaks the rock down, softening the sharp edges, preparing it to become part of the soil. It is a sign that the rocks are not separate from the air. They are in constant communication with it, slowly changing their face in response to the sky. And finally, all these processes, the grinding of glaciers, the dissolving of limestone, the rusting of iron, the erosion of wind, lead to the final, most delicate layer of the earth, the soil. It is the living skin of the planet, the pedosphere. Imagine the very top layer of the ground, a dark, rich mixture where geology meets biology. It is composed of broken down rock, sand, silt and clay, mixed with the organic remnants of fallen leaves and ancient roots. Visualize sinking your hands into cool, dark garden soil. It crumbles easily, soft and aerated. It smells of petrichor, that distinct, earthy scent released when rain falls on dry ground. This layer is thin, sometimes only a few inches deep, yet it sustains all life on land. It is a chaotic, beautiful mixture of the dead and the living. It is where the rock finally surrenders its hardness to become a cradle for seeds. It is a place of transformation, where the death of the mountain becomes the birth of the flower. Resting your mind on this image of the soft, nurturing earth, you can feel a sense of grounding. You're connected to this cycle, supported by the rock below and nourished by the soil above, held safely in the complex, comforting embrace of the world's surface. From that soft, crumbling embrace of the living soil, we travel north, or perhaps up into the high altitudes, to a place where the ground has entered a state of eternal slumber. Here, we encounter the phenomenon of permafrost, Imagine a world where the soil does not breathe in the cycle of seasons, but remains locked in a rigid, icy stillness. Beneath the thin layer of moss and lichen that thaws for a few brief weeks in summer, the earth is frozen solid, not just for a winter, but for thousands of years. It is a suspension of time, a geological pause button. Visualize the texture of this frozen ground. It is as hard as concrete, a composite of rock, sand and ice fused together by the relentless cold. This ice does not act like the slippery ice of a skating rink. Here, it acts as a cement, a binding agent that holds the landscape in a tight, motionless grip. Buried within this icy vault are the secrets of the ancient past, preserved in perfect condition. Seeds from flowers that bloomed 20,000 years ago lie here, waiting in the dark. The remains of woolly mammoths, their fur still intact, sleep in this deep freeze, protected from the decay of the warming world. It is a quiet, stoic layer of the planet, a reminder of the great ice ages that once held the globe in their sway. To walk on permafrost is to walk on a solid block of history, a hard, cold archive that lies just beneath your boots, keeping the world firm and unyielding. Resting on top of these frozen landscapes, or perhaps sitting alone in the middle of a grassy meadow far to the south, we find the lonely giants known as glacial erratics. Picture a vast green field, flat and smooth, stretching out to the horizon. In the centre of this field sits a single, massive boulder, the size of a house. It looks out of place, alien, as if it dropped from the sky. It is made of pink granite, while the bedrock beneath the field is grey limestone. It does not belong here. These stones are travellers. They were plucked from their original homes in distant mountain ranges by the colossal ice sheets of the past. As the glaciers moved, slow and inexorable, they carried these massive stones on their backs for hundreds of miles. When the ice finally melted, retreating back to the poles, it gently set these burdens down, leaving them stranded in a foreign land. They are monuments to the power of transport, solitary sentinels that have sat in the same spot for 10,000 years. Run your hand over the rough surface of an erratic in your mind. Feel the lichen clinging to it, the warmth of the sun stored in its mass. It is a symbol of stillness after a long journey, a rock that has found its final resting place far from home, sleeping peacefully in the tall grass. Where the great glaciers met the ocean, they left behind landscapes of breathtaking grandeur. Let us drift now into the deep, calm waters of a fjord. Visualize a valley carved not by a river, but by a tongue of ice so thick it scraped the earth down below sea level. When the ice retreated, the ocean rushed in to fill the void, creating a long, narrow arm of the sea that reaches deep inland, flanked on both sides by towering vertical cliffs. The water here is incredibly deep and dark, a mirror of obsidian reflecting the high stone walls and the sky above. Because the entrance to the fjord is often shallow, blocked by the debris the glacier left behind, the deep water inside is tranquil, protected from the churning waves of the open ocean. It is a place of profound silence. Sound travels clearly here, the cry of a seagull, the splash of a seal, the distant roar of a waterfall cascading down the cliff face. Imagine floating on this glass-like surface, looking up at the mountains that rise straight from the water, their peaks disappearing into the clouds. The fjord is a canyon of water, a place where the ocean penetrates the heart of the land, creating a sanctuary of calm grandeur where the water is as still as a painting. As we follow the water out of the fjord and toward the open coast, we encounter the rhythmic breathing of the ocean in the tidal flats. This is the intertidal zone, a world that exists in a state of flux, belonging to the land for half the day and to the sea for the other half. Imagine the tide receding, pulling back like a slow grey blanket to reveal miles of wet mud and sand. The ground here glistens in the sunlight, a vast flat expanse of shimmering wetness. It is textured with the ripple marks of the last waves, tiny ridges of sand that look like a miniature desert. The mud is soft, yielding, and rich with nutrients. It smells of salt and brine, a clean, sharp scent that clears the mind. As you watch, tiny bubbles rise to the surface, evidence of the microscopic life working beneath the mud. The horizon here is endless, a blur where the wet earth meets the sky. It is a landscape of reflection. When the water is shallow enough, the clouds are perfectly mirrored on the ground, so that walking here feels like walking among the heavens. It is a place of transition, a borderland that refuses to be just one thing, teaching us the beauty of the ebb and flow. In other parts of the world, where the sun is fierce and the rain is a stranger, the water evaporates completely, leaving behind a stark white beauty, the salt flats. Visualize a prehistoric lake that had no outlet, no river to drain it. Over thousands of years, the sun drank the water, leaving behind only the minerals that were dissolved within it. What remains is a landscape of blinding white, stretching as far as the eye can see. This is a salar. The ground is a hard crust of salt crunching softly underfoot like dry snow. It creates a geometric pattern on the surface, vast polygons of white crystal formed as the crust dried and cracked. The air here is incredibly dry and pure. At high noon, the white surface reflects the sun with an intensity that erases shadows, making the world feel dimensionless and ethereal. But after a rare rain, a thin film of water covers the salt, turning the entire desert into the world's largest mirror. The separation between earth and sky vanishes completely. You're floating in a sphere of blue, suspended in infinite space. It is a place of absolute clarity, a geological clean slate where the clutter of the world is bleached away by the sun and the salt. In these arid lands, the rocks themselves wear a coat of armour. As you wander from the white salt flats to the rocky outcrops nearby, notice that the boulders are dark, shiny and smooth, as if they have been varnished. This is desert varnish. It is a coating thin as a sheet of paper, composed of clay minerals and oxides of manganese and iron. This varnish is not painted on by wind or water, but by microscopic bacteria living on the surface of the rock over thousands of years. They take trace elements from the dust in the air and cement them to the stone, slowly turning the red or grey rock to a deep, lustrous black. It is one of the slowest processes in geology, growing only a hair's width every 1,000 years. It is a calendar of deep time. Ancient people used these dark, varnished canvases to carve petroglyphs, chipping away the black surface to reveal the lighter rock beneath. Visualize a canyon wall, dark and gleaming in the desert sun, inscribed with the spirals and figures of a forgotten dream. It is a protective skin, a testament to the patience of the desert, where even the rocks slowly tan under the gaze of the sun. Yet, even in the driest desert, the earth holds a secret gift. Hidden deep beneath the sand and the varnish, flowing along fault lines and cracks in the bedrock, water travels. When this pressurized water finds a path to the surface, it creates an oasis. Imagine the shock of green against the endless gold of the dunes. The water bubbles up, cool and clear, creating a pool that mirrors the palm trees leaning over it. The geology here acts as a funnel and a filter. The surrounding rock, perhaps sandstone or limestone, has acted as a sponge, collecting rain from distant mountains and carrying it underground for miles until the pressure forces it up. The air in the oasis is different, humid, sweet, and alive with the sound of birds. It is a geological miracle, a specific point where the underworld offers up its lifeblood to the surface. Resting by the edge of an oasis pool, you can feel the coolness radiating from the water, a stark, comforting contrast to the heat of the sands. It is a sanctuary, a reminder that sustenance can be found in the most unlikely of places if one knows where to look. The water that travels underground does not always stay cool. Sometimes it journeys too deep, brushing against the hot rocks near a magma chamber. It becomes superheated, turning into a pressurized engine of steam and water. This brings us to the spectacle of the geyser. Visualize a rocky basin, bleached white by minerals, with a vent in the center that leads down into the dark throat of the earth. Deep below, the water is boiling, but the weight of the water above keeps it from turning to steam until the pressure becomes too great. Suddenly, the balance tips. The water flashes into steam, expanding instantly. With a roar that shakes the ground, a column of boiling water and white mist shoots high into the air. It is a majestic release of energy, a fountain of heat dancing against the blue sky. The water sparkles like diamonds as it falls back to earth. Then, the eruption ceases, the water retreats, and the cycle begins again. Inhale the moist, warm air. It is the earth breathing, a rhythmic exhalation of heat that has been building up in the deep. It is a pulse, a heartbeat of the planet that you can watch and feel. Where this hot water flows more gently, spilling out over the edges of the vent rather than erupting, it builds magnificent architectural wonders known as travertine terraces. The hot water is rich in dissolved limestone. As it reaches the surface and cools, and as the carbon dioxide escapes into the air, the limestone can no longer stay dissolved. It turns back into solid stone, instantly. Picture a mountainside covered in a series of cascading pools. The walls of the pools are made of white travertine, smooth and curvy like flowing wax frozen in time. The water inside each pool is a stunning milky blue, warm and inviting. The water spills from the top pool to the one below, then the one below that, creating a staircase of thermal baths. The steam rises gently, curling into the cool air. The texture of the stone is grippy but smooth, warm to the touch. It looks like a frozen waterfall made of cloud and sky. It is a place where the geology invites you to step in, to float in the warmth provided by the Earth's core, cradled in a basin built by the water itself. Finally, in the areas where the heat is intense but the water is scarce, we find the fumaroles. These are the dry vents, the openings in the crust where the Earth simply sighs. There is no fountain of water here, only a plume of steam and gas escaping from a crack in the rocky ground. Imagine walking through a volcanic valley in the early morning. The ground is warm beneath your feet. All around you, pillars of white steam rise silently from the earth, twisting and turning in the breeze. They look like the ghosts of the underground, escaping into the daylight. There is a faint scent of sulfur, earthy and distinct, a smell that speaks of the deep chemistry of the planet. Listen to the sound, a soft, continuous hissing, like a kettle left on a low boil, or a long, drawn-out shh. It is a sound of release. The pressure is not building up here. It is being let go. The fumarole is a safety valve, a gentle way for the planet to cool itself. Watching the steam dissipate into the air, fading into nothingness, you can feel your own tension drifting away with it, carried off on the breath of the world, leaving you empty, light, and perfectly at peace. The steam that rises from the fumaroles eventually disperses, fading into the blue, leaving behind a silence that feels older than the sky itself. It is in this profound quietude that we find the aftermath of the Earth's greatest exhales, the caldera. Imagine standing on the rim of what looks like a vast circular valley miles across. This is not a crater formed by a meteorite striking from above, but a depression formed by the Earth collapsing from within. Long ago, a colossal volcano stood here. When it emptied its magma chamber in a cataclysmic eruption, the mountain, no longer supported by the molten rock beneath, fell inward, creating this magnificent bowl. Now, the fire is gone. The violence has been replaced by a deep, abiding peace. Over centuries, rain and snow have filled this basin, creating a lake of crystalline purity. Picture the water, a sheet of deep, royal blue, so still it mirrors the clouds with perfect fidelity. Because the caldera has no inlet streams bringing in sediment, the water is clearer than any other on Earth. You can see down into the depths, past submerged rocky spires that once stood in the open air. A small island might rise in the centre, a wizard island, the tip of a new small volcano slowly growing in the womb of the old one. The air here is cool and clean. Standing on the rim, looking down at this sleeping giant, you feel a sense of containment, as if the earth is holding this water in a pair of cupped stone hands, protecting it from the chaos of the world outside. As we descend from the high rim of the caldera toward the rocky slopes where the ancient lava flows cooled, we encounter a strange and beautiful geometry. The earth, usually so chaotic and organic in its shapes, here decided to follow a strict mathematical order. These are the basalt columns. Visualize a cliff face that looks like a pipe organ made of stone, or a honeycomb built by giants. Hundreds of tall vertical pillars stand shoulder to shoulder, each one a perfect hexagon. This order emerged from the cooling of a massive lava lake. As the thick, hot basalt began to lose its heat to the atmosphere, it shrank. Just as mud cracks when it dries in the sun, the lava cracked. But because the cooling was so slow and uniform, the cracks formed a perfect hexagonal pattern, propagating downward, turning the molten rock into a forest of stone pillars. Picture stepping onto the tops of these columns, like walking on a cobblestone street laid by nature. The stone is dark, grey-black, and cool to the touch. The edges are sharp, the face is flat. It creates a rhythm in the landscape, a visual repetition that is deeply soothing to the eye. It is a reminder that even in the heart of fire there are laws of physics weaving structure, turning a river of chaos into a monument of order. Not all lava cools into heavy, dense columns. Some of it, filled with gas and air, cools so quickly it becomes a stone that defies gravity. This is pumice. Imagine a rock that is more air than stone. It is the froth of a volcano, the foam on top of a magma chamber, frozen in an instant as it was ejected into the cool air. Pick up a piece of pumice in your mind. It is rough and scratchy, pale grey or cream-coloured, filled with millions of tiny bubbles. When you hold it, your mind expects the weight of a rock, but it feels light as a feather, a ghost of a stone. If you were to toss it into the caldera lake we just visited, it would not sink. It would bob on the surface, drifting with the breeze. Visualize vast rafts of this floating stone drifting on the ocean after an island eruption, travelling for thousands of miles, carrying seeds and tiny travellers to new lands. It is a rock that has learned to fly, or at least to swim. It represents the union of earth and air, a substance that bridges the gap between the solid ground and the atmosphere, floating lightly on the currents of the world. The water that supports the floating stone also has the power to undermine the solid ground. In lands where the bedrock is made of thick limestone, the groundwater eats away at the stone from below until the roof can no longer hold. The ground sighs and gives way, revealing a cenote. Picture walking through a dense, humid jungle. The air is thick with the scent of green leaves and damp earth. Suddenly the forest floor opens up. You look down into a deep, circular pit, a shaft of light cutting through the canopy. At the bottom lies a pool of fresh water, glowing with an ethereal turquoise luminescence. Long vines and tree roots dangle from the rim, reaching down 50 feet to drink from the water below. It looks like an eye of the earth staring up at the heavens. The water is cool and incredibly clear, filtered by the limestone. Swimming in a cenote feels like floating in space. The water is so transparent that you can see every stalactite beneath the surface, every fallen leaf resting on the bottom. It is a secret garden, a hidden oasis protected by walls of stone, a quiet, sacred space where the underworld meets the sky. If we zoom out from the single cenote and look at the landscape as a whole, we see what happens when the water dissolves the land on a massive scale. This is karst topography. But let us look at a specific dreamlike variety, the tower karst. Imagine a landscape that looks like a traditional Chinese painting come to life. The land is not flat, nor is it a rolling hill. Instead, solitary, vertical towers of rock rise abruptly from the flat green fields. These stone needles, hundreds of feet tall, are the survivors. The rock around them has been dissolved and washed away by millions of years of rain and river flow, leaving only these resistant pillars standing. They are draped in clinging vines and stunted pine trees. Mist often weaves between them, obscuring their bases so they appear to float on clouds. The silence here is broken only by the echo of birds calling from the cliffs. It is a landscape of verticality and negative space, where the emptiness between the mountains is just as important as the mountains themselves. It feels ancient and wise, a stone forest that has watched empires rise and fall, remaining aloof and shrouded in its own misty mystery. Through these valleys of stone towers, water must find a way. A river here does not run straight. It is old, and it takes its time. It moves in great sweeping loops known as meanders. Visualize a river from high above, looking like a glittering silver ribbon dropped carelessly onto a green velvet cloth. It curves back and forth, turning almost in complete circles. This is the motion of fluid seeking the path of least resistance, dancing with the landscape. As the river flows around a bend, it moves faster on the outside edge, eating away at the bank, and slower on the inside edge, dropping soft sand. Over time, the loops become more extreme. Eventually, the river desires a straighter path. It cuts through the narrow neck of land, leaving the old loop behind. This abandoned curve becomes an oxbow lake. Picture this crescent-shaped pool, isolated from the flowing river. It is a still, quiet sanctuary, shaped like a horseshoe. Lilies grow here, and herons stand motionless in the shallows. It is a memory of the river, a ghost of where the water once flowed, preserved in the landscape as a calm, reflecting pool. The river, having shed its old skins and travelled hundreds of miles, finally approaches its end. It meets the sea. Here, the current slows to a halt, and the water can no longer carry the burden of silt and sand it has brought from the mountains. It gently lays this burden down, creating a delta. Visualize the coast from space. The river fans out like the veins of a leaf, or the roots of a tree, dividing into dozens of smaller channels known as distributaries. This is land being born. The sediment piles up, creating rich, marshy islands that extend out into the ocean. The colours here are vibrant, the brown and gold of the silt mixing with the deep blue of the sea and the bright green of the marsh grasses. It is a place of mixing. Fresh water meets salt, land meets ocean. It is soft ground, shifting and muddy, teeming with life. The delta is a fan of creation, where the destruction of the mountains upstream, the erosion we spoke of earlier, is transformed into new territory. It is a gift from the heights to the depths, a continuous offering of earth to the sea. Not all sediment travels by water, some travels on the wind. Let us drift to the vast central plains of the continents to find the Lewis. Imagine a landscape of soft rolling hills, coloured a warm pale yellow or buff. This soil is made of silt, particles finer than sand but coarser than clay, ground up by ancient glaciers and blown by the wind in massive dust storms thousands of years ago. The dust settled here, creating a blanket hundreds of feet thick. Lewis is unique. It is soft enough to crumble in your hand, feeling like flour or talc, yet it is strong enough to stand in vertical cliffs without collapsing. The wind sings as it blows over these hills, rustling the tall grasses that love this mineral-rich ground. It is the most fertile soil on Earth. When you look at it, you're seeing the result of a global redistribution, the wind painting the continents with the dust of the Ice Age. It feels warm, dry, and soft, a landscape that seems to absorb sound, creating a muffled, cozy quietness across the plains. Buried within these layers of silt, or found in the banks of the quiet oxbow lakes, is a material that feels slick and heavy in the hand. Clay. This is the end product of the weathering of rocks like granite. The feldspar crystals, once hard and pink, have broken down chemically into microscopic flat plates. Visualize walking barefoot on a riverbank. Your feet sink into the cool grey mud. It squeezes between your toes, smooth and slippery. This material is plastic. It has memory. If you press your thumb into it, the impression remains perfectly. It is the earth in its most malleable form. For thousands of years, human hands have gathered this soft earth, shaped it into bowls and vessels, and subjected it to fire. In the heat, the clay transforms. It returns to the hardness of rock, but in a shape chosen by the artist. When you hold a ceramic mug, you are holding a piece of metamorphic geology, a stone formed not by the weight of mountains, but by the warmth of a kiln. It represents the Earth's willingness to be shaped, to work in partnership with us, holding our water and our food in its hardened embrace. Finally, resting deep in the gravels where the clay has been washed away, hidden in the bends of the river where the water slows down, lies a substance of intense weight and luster. Gold. It is born in the collision of stars, but it lives in the geology of the Earth. Because it is so heavy, much heavier than the granite or quartz sand around it, it settles to the very bottom of the riverbed, finding the deepest cracks and pockets. Visualize a prospector's pan, swirling with black sand and water. As the lighter sand washes away, a gleam appears, a tiny flake of pure, eternal yellow. It does not rust like iron. It does not tarnish like silver. It glows with the same warm light as the sun. This is a placer deposit, a concentration of heavy minerals sorted by the patient agitation of the river. To find it, one must understand the flow of water and the weight of stone. It is the Earth's hidden treasure, a spark of cosmic light buried in the mud. Seeing that glint in the dark gravel triggers a primal fascination, a connection to the noble elements that endure unchanged, while the mountains erode and the rivers shift their courses around them. It is a heavy, warm anchor in a changing world. While the heavy, golden warmth of the placer deposits rests in the riverbeds, a different kind of treasure is born not in the flowing water, but in the crushing, absolute depths of the mantle. Far deeper than any mine has ever reached, in a realm of darkness and immense pressure, we find the birthplace of diamonds. Imagine a single atom of carbon, the same element that makes up the graphite in a pencil or the soot of a candle flame. Down here, 90 miles beneath your feet, the weight of the world overhead is so staggering that it forces these carbon atoms to bond in a way that defies destruction. They lock arms in a perfect three-dimensional lattice, a pyramid of strength. Visualize this crystal growing slowly in the magma soup of the deep earth. It is not yet the sparkling gem you see in a ring. It is a rough octahedral stone, often looking like two pyramids glued base to base. It is the hardest natural substance known to man. To touch the surface of a raw diamond is to touch a material that refuses to yield. It is adamantine, a word that means untamable. In the cold light of day, it disperses light into a spectrum of rainbows, but in the deep earth, it is simply a vessel of potential, a knot of pure crystallized patience. It reminds us that under enough pressure, the common stuff of life can be transformed into something invincible and brilliant. But how does such a deep creation reach the surface? It requires a vehicle, a geological elevator that moves with terrifying speed. This is the kimberlite pipe. While most magma moves slowly, rising like honey, the magma that carries diamonds is different. It is rich in gas and water, volatile and impatient. Visualize a carrot-shaped tube of rock punching its way upward through the crust. It moves at supersonic speeds, shattering the rock above it, propelled by the expanding gases within. It is a vertical cannon shot from the mantle. As this magma races toward the sky, it rips chunks of rock from the walls of the conduit and carries them along. These are the diamonds, the passengers on a violent journey to the light. When the eruption finally breaches the surface, it leaves behind a crater that quickly fills with debris. The rock that remains, the kimberlite, is a strange blue-grey matrix, a chaotic fruitcake of different stones. Buried within this softer rock are the diamonds, surviving the journey because of their incredible hardness. They are the emissaries from the deep, brought to us by one of the Earth's rare moments of true velocity. Often, these kimberlite pipes bring up more than just diamonds. They bring up pieces of the mantle itself, giving us a glimpse of the Earth's interior colour. This is the realm of olivine and peridot. If you could peel away the crust of the earth like the skin of an orange, the fruit underneath would be a vibrant olive green. This is the dominant mineral of the upper mantle. Imagine standing on a rare beach in Hawaii or the Canary Islands, where the sand is not white or black, but a sparkling grassy green. These are crystals of olivine that have weathered out of the volcanic rock. They are the gems of the underworld. When olivine is clear and gem quality, we call it peridot. Visualize a crystal of peridot held up to the sun. It glows with a soft, oily luster, a verdant light that feels alive. It is the colour of spring, yet it comes from a place of infernal heat. Unlike other gems that form in the cool crust, olivine is unstable on the surface. It yearns for the high pressure of the deep. Slowly, over eons, rain and air will break it down, but for a moment, it offers us a beautiful green window into the heart of the planet. When this green mantle rock is exposed to water, perhaps at a mid-ocean ridge where the sea seeps into hot cracks, it undergoes a profound transformation, becoming serpentinite. The heat and water soften the hard olivine, turning it into a mineral that feels greasy and slick, like hard soap or the skin of a reptile. Visualize a cliff face made of this rock. It is a swirl of dark greens, light greens and blacks, mottled and veined like the scales of a giant serpent. The texture is unique. Geology calls it slicken sides. These are polished, grooved surfaces where the rocks have slid past each other during fault movements. Because serpentinite is soft and slippery, it acts as a lubricant for tectonic plates, allowing them to slide more easily. Run your hand over a piece of polished serpentine in your mind. It feels cool, waxy, and organic, almost as if it were once alive. It is the stone of transformation, representing the moment when the dry fire of the mantle meets the cooling hydration of the ocean, creating something smooth, beautiful, and yielding. If we continue down the path of softness, we arrive at the softest mineral in the entire geological kingdom, talc. If diamond is a 10 on the scale of hardness, talc is a 1. It is the gentle opposite of the diamond's rigidity. Imagine a stone that you can scratch with your fingernail. It feels incredibly soft, almost creamy or soapy to the touch, which is why the rock form is often called soapstone. Visualize a block of soapstone, grey and matte. It absorbs heat slowly and radiates it back just as slowly, making it warm to the touch long after the sun has set. Because it is so soft, it has been carved by human hands for thousands of years into bowls, statues and seals. It offers no resistance. It accepts the shape we give it. In a world of jagged granite and sharp flint, talc is a reminder of the gentleness that exists in the stone world. It is a mineral formed by the metamorphism of magnesium-rich rocks, bathed in warm fluids until all the tension is washed away, leaving behind a substance that is pure softness, a stone that feels like silk. Often found alongside these softer rocks is a mineral that plays with light and structure in a dazzling way, mica. This is the glitter of the geological world. Walk through a granite landscape on a sunny day and look at the path beneath your feet. The tiny flashes of light, the sparkles that catch your eye, are flakes of mica. Visualize a large crystal of mica. It is not a block, but a book. It is composed of incredibly thin, perfect sheets stacked one on top of the other. You can peel these layers apart with your fingers, each one thinner than paper, transparent and flexible. One type, muscovite, is clear and silvery. In the days before glass, it was used for window panes in Russia, known as Muscovy glass. Another type, biotite, is black and shiny. These minerals form perfect flat cleavage planes. They represent the concept of cleavage, the tendency to break along smooth parallel lines in its most perfect form. Holding a sheet of mica up to the light, looking through its silvery haze, is like looking through a veil. It is a mineral that speaks of layers, of the ability to separate and remain whole, adding a touch of shimmer to the stoic grey of the mountains. When millions of these tiny flat minerals, micas and clays, are aligned by the immense pressure of a mountain-building event, they create the rock known as slate. We spoke of sedimentary shale earlier, the quiet mud of the sea floor. Now, imagine that mud squeezed by the collision of continents. The pressure forces all the microscopic flakes to turn and face the same direction, like a school of fish turning in a stream. This alignment creates a rock that splits perfectly into thin, flat plates. Visualize a roof tiled with slate. The tiles are dark grey, perhaps tinged with purple or green. They are smooth but textured with the grain of the stone. When rain falls on a slate roof, it creates a distinct rhythmic sound, a sharp, clean patter that has lulled people to sleep for centuries. Slate is the sound of protection. It is impermeable. Water cannot penetrate it. It is the first step in the metamorphic journey, a rock that has been organised by stress, gaining a new strength and a new ability to shelter us from the storm. If we increase the heat and pressure even further, deep in the roots of the mountain, the slate transforms, growing larger crystals until it becomes gneiss. This is a rock that wears its history in stripes. Imagine a boulder that looks like a frozen tiger or a zebra, with alternating bands of white quartz and black mica. This gneissic banding occurs when the rock is under such extreme stress that the minerals separate from one another. The light minerals migrate to one band, and the dark minerals to another. They segregate to survive. The bands are often wavy and contorted, showing how the rock flowed like plastic millions of years ago. Gneiss is a high-grade metamorphic rock. It has been to the edge of hell and back. It is dense, hard, and incredibly beautiful in its complexity. To look at a piece of gneiss is to look at a turbulent storm frozen in stone. It tells us that even in the most crushing situations, order can be found, and distinct identities can emerge from the chaos of the mix. Sometimes the rock is transformed not by the slow pressure of the earth, but by a sudden, violent strike from the heavens. We return to the surface to witness the birth of a fulgurite. Imagine a vast sand dune under a darkening sky. A thunderstorm rolls in, heavy with electricity. A bolt of lightning, hotter than the surface of the sun, strikes the dune. In a fraction of a second, the sand grains in the path of the bolt are vaporized and melted. As the lightning travels down into the ground, it fuses the sand into a hollow glass tube. This is fossilized lightning. Digging one out of the sand is like excavating a root made of glass. The outside is rough and sandy, but the inside is smooth, shiny glass, often grey or tan. These tubes branch out like the lightning bolt itself, capturing the exact shape of the energy discharge. It is a fragile, instantaneous creation, a permanent record of a fleeting moment of power. It represents the marriage of sky and earth, where the ethereal energy of the storm is grounded and given a physical form that can be held in the hand. From the instantaneous flash of lightning, we spiral back into the deep, slow curve of biological time with the ammonite. These are the fossils of ancient sea creatures, relatives of the squid and nautilus, that swam in the oceans for hundreds of millions of years. Their shells are masterpieces of natural mathematics. Visualize a stone spiral, perfectly proportioned, widening as it turns. This is the golden ratio in calcium carbonate. The creature lived in the outermost chamber, and as it grew, it built a new, larger chamber and moved forward, sealing the old one off behind a wall of pearly shell. When these shells are fossilized, the empty chambers are often filled with minerals, calcite, pyrite, or agate. Sometimes the original mother-of-pearl sheen is preserved, flashing with iridescent reds and greens known as ammonite. Holding an ammonite is like holding a time machine. The spiral draws the eye inward to the center, to the beginning, and outward to the edge, to the end. They swam in seas that covered continents which no longer exist. They remind us of the beauty of growth, of moving forward while carrying the structure of our past with us, calcified into a beautiful, enduring geometry. The spiral of the ammonite draws our mind inward, coiling through the corridors of time, but there is another vessel of preservation that captures not just the shape of life, but the very light of a prehistoric day. drift with me now into the warm golden glow of amber. Unlike the cold minerals of the deep earth, this gem began its life as a fluid, a sticky aromatic resin bleeding from the bark of ancient pine trees in a forest that stood 50 million years ago. Visualize a humid, sun-drenched afternoon in this primeval woodland. The air is thick with the scent of pine needles and damp moss. A drop of golden sap, heavy and viscous, rolls slowly down the trunk of a great tree. In its slow descent, it traps a tiny moment of existence, a gnat dancing in the air, a small spider spinning its web, or perhaps a single delicate air bubble. The resin flows over them, sealing them instantly in a sterile, airtight tomb. Over millions of years, the forest falls, the sea rises, and the trees are buried under sediment. The volatile oils in the resin slowly evaporate, and the substance hardens, polymerizing into the gemstone we know today. Holding a piece of amber is like holding a solidified ray of sunlight. It feels warm to the touch, unlike the coolness of quartz or granite. It is lightweight, almost floating in the hand. When you look into its depths, you're looking through a window that has not been opened for eons. The insect trapped inside is perfect, every hair on its legs, every facet of its eye preserved with absolute fidelity. It is a time capsule of golden transparency, a suspended animation where the flow of time was stopped in a single sticky instant. It reminds us that even the most fleeting, fragile moments, the buzz of a fly, the fall of a leaf, can be caught and held forever in the Earth's memory. While amber preserves the body of the small, other geological records preserve the movements of the large. We shift our gaze from the resin on the tree to the mud at the water's edge, where we find the ghostly evidence known as trace fossils. These are not the bones of the creatures, but the marks of their behaviour, the shadows of their actions left in the stone. Imagine walking along the shore of a shallow tropical sea in the Jurassic period. A massive dinosaur weighing tons walks heavily across the tidal flat. Its feet sink deep into the soft, wet clay, leaving deep, three-toed impressions. The sun bakes the mud hard. Later, a gentle layer of sand washes over the tracks, filling them in and protecting them. Millions of years later, the mud has turned to shale and the sand to sandstone. We split the rock open, and there, perfectly cast, is the footstep. But it is not just footprints. Trace fossils can be the delicate, winding trails of a worm on the ocean floor, or the burrow of a crab seeking shelter. They can even be the impressions of raindrops from a storm that fell 200 million years ago. Visualize a slab of rock pitted with small circular craters, the fossilized splash of ancient rain. To touch these marks is to connect with a specific event, a Tuesday afternoon in the deep past when an animal walked here, or a storm broke the heat of the day. It is a hauntingly beautiful reminder that the Earth records not just the existence of life, but the living of it, the walking, the crawling, the breathing, and the weather that surrounded it all. The recording of weather and time brings us to the quiet, rhythmic accumulation found in the depths of glacial lakes, the varves. These are the pages of the Earth's calendar, written in alternating bands of light and dark silt. Visualize a cold lake sitting at the foot of a glacier. In the summer, the sun melts the ice, and the water rushes into the lake, milky white with heavy sand and silt. This coarse material settles quickly to the bottom, forming a pale, thick layer. Then, winter descends. The glacier stops melting. The surface of the lake freezes over, sealing the water in a quiet, dark stillness. Under the ice, the very finest particles of clay, which have been floating suspended in the water for months, finally have the peace to settle. They drift down slowly, forming a thin, dark layer on top of the summer sand. Year after year, this cycle repeats. Summer, winter, light, dark. When we dig into the floor of these ancient lakes, we find rock that looks like a barcode or the pages of a closed book. We can count these layers just as we count the rings of a tree. We can see a thick layer and know that summer was long and warm. We can see a thin layer and know that winter arrived early. It is a mesmerizing pattern of duality, a geological metronome that has clicked back and forth for millennia. It offers a sense of immense order, a comforting reassurance that the seasons have always turned, the ice has always melted and frozen, and the Earth has kept a faithful tally of every passing year in the silence of the lake bed. Sometimes the rock records patterns that mimic life so perfectly they deceive the eye. We drift now into the cracks and fissures of limestone or sandstone to find dendrites. You may have seen these on a slab of stone and thought you were looking at a fossilized fern or a delicate moss trapped in the rock. They branch out in intricate fractal patterns, looking like the frost on a window pane or the veins of a leaf. But these are not fossils, they are crystals. They are formed by manganese oxide dissolved in water, seeping through hair-thin cracks in the rock. As the water evaporates, the mineral crystallizes, branching out in search of space, following the path of least resistance. This is the same physics that shapes a river delta, a lightning bolt, or the blood vessels in your lungs. Visualize the stark contrast, the pale, creamy background of the limestone and the stark black silhouette of the dendrite. It is a painting made by chemistry. It feels cool and smooth, looking like a Japanese ink wash painting. These pseudo-fossils remind us that the laws of nature, the laws of branching and growth, are universal. They apply to the living and the non-living alike. The stone dreams of being a plant, imitating the organic world with a startling mathematical beauty, creating a frozen forest that never needed the sun to grow. From the organic branching chaos of dendrites, we move to the absolute rigid perfection of pyrite. Here, nature abandons curves and embraces the straight line and the right angle. Deep underground, where iron and sulfur meet in a low-oxygen environment, they combine to form crystals of shocking geometry. Visualize a perfect cube of gold-coloured metal, embedded in a matrix of grey slate. It looks like it must have been machined, cut by a laser, or polished by a jeweller. But no, this cube grew this way, atom by atom. The corners are sharp, the faces are perfectly flat mirrors. This is fool's gold, but to dismiss it as a fake is to miss its structural wonder. It is heavier than you expect, dense and cold. Its metallic luster is bright and brassy. Sometimes pyrite forms in the shape of a pyritohedron, a 12-sided geometric solid that looks like a futuristic artifact. To hold a perfect pyrite cube is to hold evidence of the crystal lattice, the internal grid that dictates the shape of the solid world. It represents stability, grounding, and the hidden order that exists beneath the chaotic surface of reality. It sparkles with a distinct brassy confidence, a mineral that knows exactly what it is and refuses to be anything other than geometrically perfect. While pyrite engages our sense of sight and weight, another iron mineral engages a sense we do not consciously possess: magnetism. We speak of magnetite or lodestone. This is a heavy, black, metallic stone that looks unassuming, like a piece of industrial iron. But it holds a secret power. It is the only rock that is naturally magnetized. Visualize a piece of magnetite lying on a table. If you bring a small iron needle near it, the needle will jump, pulled by an invisible tether. If you suspend a piece of magnetite on a string, it will slowly, groggily turn until it aligns with the magnetic North Pole of the Earth. Ancient sailors used this stone to find their way across featureless oceans. It is a rock that knows where north is. Feel the strange, subtle vibration of connection when you hold two magnets close together, the push and the pull. That force resides inside this stone. It is a bridge between the physical rock and the invisible energy fields that surround our planet. It reminds us that the Earth is not just a ball of dirt, but a giant magnet surrounded by a force field that guides the birds in their migration and protects us from the solar wind. Holding magnetite is like holding a receiver tuned to the silent, constant broadcast of the planet's core. We move from the dark, invisible forces of magnetite to a stone that plays with visible light in the most spectacular way: labradorite. At first glance, this rock appears to be a dull, dark grey mineral, perhaps a component of a common kitchen counter. It seems unremarkable, blending into the shadows. But you must move it to understand it. Visualize holding a polished stone of labradorite in your hand. You tilt it back and forth in the light. Suddenly, at a specific angle, the stone ignites. A flash of electric blue, iridescent gold, or peacock green sweeps across the surface. This is labradorescence. It is not a pigment on the surface. It is light interacting with the microscopic layers of feldspar inside the stone. The light enters, bounces off the internal structures, and returns to your eye as a pure spectral colour. It is like holding the aurora borealis trapped in a rock. One moment it is stone, cold and grey. The next it is light, vibrant and alive. This optical magic reminds us that beauty is often a matter of perspective. It requires interaction. It requires you to turn the object, to look at it from a new angle, to reveal the hidden fire that waits beneath the unassuming surface. It is the stone of transformation and hidden potential, flashing its secret colours only to those who take the time to look. Far more delicate than the feldspar of labradorite is the hydrated silica known as opal. We travel to the dry red deserts of Australia to find this gem. Unlike most crystals, which have a rigid grid structure, opal is made of billions of microscopic spheres of silica stacked together like oranges in a crate. Between these spheres is water, ancient rain trapped millions of years ago. When white light enters this grid of spheres, it is split apart, diffracted into every colour of the rainbow. Visualize a precious opal, a milky white or deep black stone that seems to contain a galaxy of coloured fire. Neon reds, electric greens, ultraviolet violets. They dance and shift as you move the stone. This is play of colour. It looks like oil on water or a hologram. Because opal contains water, it is fragile. If it gets too dry, it can crack or craze. It is a stone that is intimately tied to the climate. It feels soft and smooth, almost like plastic because it is not as hard as quartz. It represents the marriage of the desert and the water, a gemstone born in arid lands from the memory of ancient inland seas. It is a dreamscape in a pebble, a chaotic, swirling nebula of colour that defies the static nature of stone. From the internal flowers of light in opal, we turn to a flower made of solid sand, the desert rose. In the shallow salt basins and arid dunes, where groundwater rich in gypsum evaporates in the scorching heat, crystals begin to grow within the sand itself. But they do not form blocks or cubes. They form flat circular plates. As these plates grow, they intersect and overlap, fanning out in a circular pattern that perfectly mimics the petals of a rose in full bloom. The sand grains are trapped inside the crystal as it grows, giving the flower the same colour and texture as the surrounding desert, tawny, sandy, and rough. Visualize a cluster of these stone roses lying on the surface of the dunes. They're dry, dusty, and brittle. They are flowers that will never wilt, never need water, and never fade. They are the desert's attempt at botany, a stark geometric beauty born of evaporation and thirst. Holding a desert rose, you feel the grit of the sand and the sharp edges of the crystal plates. It is a symbol of resilience, a complex and poetic shape rising from the dry, shifting barrenness of the dunes. Finally, we travel back to the very beginning of the story, to the warm, shallow waters of a primordial coastline to find the stromatolites. These look like simple, rounded boulders or rocky domes rising out of the surf. They appear to be nothing more than lumpy stones. But cut one open, or look closely, and you see fine, intricate layers, like a stack of thousands of distinct sheets. These are not just rocks. They are the work of the first architects of the planet. Billions of years ago, colonies of cyanobacteria, blue-green algae, lived in sticky mats on the seafloor. During the day, they would trap sediment and sand in their sticky coating. At night, they would grow through the sediment to reach the light again the next day. Layer by layer, grain by grain, year by year, they built these stone mounds. But their greatest gift was not the rock, it was the air. As they lived, they photosynthesized. They exhaled oxygen. Before stromatolites, the Earth's atmosphere was toxic. These silent, slime-building colonies, working patiently over billions of years, filled the skies with breath. Every breath you take right now, in this moment of relaxation, is a gift from these ancient stone builders. Visualize these humble grey mounds in a turquoise bay, the tide gently washing over them. They are the monuments to the slow, quiet persistence of life, the origin of the blue sky, and the deep, deep ancestors of the living world, sitting quietly in the surf, watching the world they helped create. From the breath of those ancient stromatolites, a new world was born, one where oxygen began to drift freely through the oceans. This brings us to a vast planetary painting known as the banded iron formations. Visualize a primordial sea billions of years ago. The water is heavy with dissolved iron, a metallic ocean waiting for a change. As the oxygen released by the stromatolites mingled with this iron-rich water, a chemical reaction of global proportions occurred. The iron rusted. It rained down from the water column, settling on the seafloor in distinct layers of red, steely grey and deep black. Imagine standing before a cliff face composed entirely of these ancient stripes. It looks like a code, a barcode of the planet's early atmosphere. Alternating bands of iron-rich hematite or magnetite and iron-poor chert or shale create a mesmerizing rhythm of colour. Run your hand over the stone. It is cold, dense, and incredibly heavy. The red layers speak of the oxidation, the great rusting of the earth, while the grey layers speak of the quiet intervals between. These formations are the backbone of our modern world, the source of the steel in our skyscrapers and cars, yet they remain a beautiful, silent record of the moment the earth first took a deep breath. To look at them is to witness the chemical marriage of the ocean and the air, preserved in a heavy magnetic slumber. As the oceans changed, so too did the land. We drift forward in time to the great sweltering swamps of the Carboniferous period. Here, giant ferns and towering trees fell into the stagnant black water of the marshes, saved from decay by the lack of oxygen. Layer upon layer of plant matter accumulated, pressed down by the weight of time until it transformed into the black lustrous rock we know as coal. Visualize a seam of coal, a vein of absolute blackness running through the lighter rock. Pick up a piece of anthracite, the highest grade of coal. It is not dirty or sooty, it is hard, shiny and smooth, reflecting the light like dark glass. It feels light in the hand, much lighter than the iron ore we just touched. This rock is essentially stored sunlight. The energy of a sun that shone 300 million years ago was captured by the leaves of an ancient forest, buried, compressed, and concentrated into this solid block of carbon. When it burns, it is releasing that prehistoric summer day back into the world. It is a stone of memory, a fossilized battery that holds the heat of a forgotten era within its brittle, obsidian-like structure. It reminds us that nothing is lost, only changed, and that the warmth of the past can be awakened in the present. While the forests were turning into coal on the land, a different kind of alchemy was happening in the depths of the oceans. Here, billions of microscopic plankton and algae lived and died, raining down into the oxygen-starved mud of the seafloor. Buried under miles of sediment, cooked by the heat of the earth, their organic remains transformed into the thick, viscous liquid of petroleum. Imagine this rock oil, not as it is in a barrel, but as it exists in nature, filling the tiny pore spaces of a sandstone reservoir deep underground, like water held in a hard sponge. It is a hidden ocean of black gold trapped beneath a cap of impermeable shale. It is the Earth's blood, warm and pressurized. Sometimes this oil escapes its trap and seeps to the surface. Visualize the La Brea tar pits, or a natural oil seep. The substance is thick, sticky, and smells of asphalt and deep earth chemistry. It creates calm, iridescent pools that reflect the sky with a dark, oily sheen. This fluid is the liquid legacy of ancient marine life, a concentration of biological history that flows through the veins of the crust. It speaks of the slow, pressure cooker transformation of life into energy, hiding in the dark, waiting to be found. Often, this black gold is trapped by a moving wall of white crystal. We speak now of the salt domes. Deep beneath the surface, ancient layers of salt, left behind by evaporated oceans, begin to feel the crushing weight of the rocks above them. But salt is unique. Under pressure, it does not break. It flows. It behaves like a slow-moving glacier of crystal. Visualize a massive column of pure white salt miles wide, pushing its way upward through the heavy layers of rock, rising like a balloon of wax in a lava lamp. As it rises, it bends and breaks the rock layers around it, creating traps where oil and gas can accumulate. But look at the salt itself. It is pure, crystalline halite. Inside these domes, the salt is so dry and so tight that it is perfectly impermeable. We mine vast caverns into these domes, creating cathedrals of white crystal underground. The walls sparkle in the lamplight, tasting of the ancient sea. It is a world of sterile purity, a geological movement that happens in slow motion, the salt refusing to be buried, rising buoyantly toward the surface in a silent crystalline resurrection. Within the rocks that the salt pushes past, there are often secret cavities, hollow spaces that hold a surprise for the seeker. These are the geodes. From the outside, a geode looks like nothing more than a rough, lumpy spherical rock, perhaps a dusty grey or brown. It is unassuming, easily overlooked in a riverbed or a desert plain. But break it open, and you reveal a hidden palace. The interior is lined with crystals growing inward toward the center. Visualize a cavity filled with purple amethyst, the crystals large and faceted, catching the light in a dazzling display of violet fire. Or perhaps it is lined with clear quartz or blue chalcedony. These crystals grew from mineral-rich water that seeped into a bubble in cooling lava or a cavity in limestone. Protected from the outside world, they had the freedom to grow into perfect shapes. A geode is a metaphor for inner beauty, a reminder that the most treasures are often hidden inside a rough shell. Holding the two halves of a cracked geode, you're the first person to ever see this specific sanctuary of crystals, a secret kept by the earth for millions of years. Similar to the geode, but solid to the core, is the thunder egg. While a geode is a hollow cave, a thunder egg is a solid nodule, formed within the rhyolite flows of ancient volcanoes. To the uninitiated eye, it looks like a baseball-sized rock with a rough, knobby surface, but cut it in half with a diamond saw and polish the face, and you gaze into a star. The center of a thunder egg is filled with agate, jasper, or opal. Often, the filling forms a star-shaped pattern, with points radiating outward, a result of the rock shrinking and cracking as it cooled, then being filled by silica-rich fluids. Visualize the colors: swirls of sky blue, bands of sunset orange, mossy greens, all framed by the rough grey outer shell. The polish is smooth as glass, cool to the touch. These are the eggs of the volcano, distinct geological entities that grew within the lava. They are heavy, dense, and compact. Each one is a unique painting, a chaotic abstract art piece created by the cooling of silica gel, frozen in stone. They offer a sense of solidity and completeness, a self-contained world of colour wrapped in a protective husk. Sometimes, the earth builds spheres not in fire, but in the quiet mud of the seafloor. These are the concretions. Unlike the thunder eggs, these are sedimentary formations. Visualize a vast, sandy beach where the tide has eroded the cliffs. Scattered across the sand are massive, perfectly round boulders, some as large as a car. These are the Meraki boulders, or cannonball concretions. They grow like pearls. A small nucleus, a shell, a leaf, a piece of bone becomes the center. Mineral cement, usually calcite, precipitates out of the groundwater, and gathers around this center layer by layer, growing outward in all directions equally. The result is a perfect sphere of hard stone embedded in softer rock. When the soft rock erodes away, the giant spheres fall out, looking like the marbles of the gods left on the beach. Some are smooth and grey, others are rusty and rough. Touching one of these giant spheres, you feel the curvature of nature, the tendency of the universe to organise itself into round shapes. They feel ancient and alien, sentinels of geometry standing guard against the surf, enduring the waves that wash over them. Occasionally, these concretions crack internally as they dry, creating a specific and beautiful variety known as the septarian nodule. Imagine holding a smooth, grey, oval stone, polished to a high sheen. The surface is patterned with a network of yellow or brown cracks that look like the scales of a turtle or the skin of a dragon. This is why they are sometimes called dragon stones. These formed as balls of mud on an ancient sea floor. As the mud dried and shrank, it cracked on the inside. Later, fluids rich in yellow calcite or brown aragonite seeped in and filled the cracks. The result is a stunning contrast: the matte grey of the limestone mud and the crystalline honey-coloured veins of the calcite. Visualise a slice of this stone. The yellow starburst pattern in the centre stands out against the dark background. It feels smooth, heavy, and comforting. It is a stone that speaks of healing, of breaks that have been filled and made beautiful. It tells the story of shrinkage and expansion, of a void created and then filled with crystal light, creating a mosaic of earth tones that feels warm and grounding. We have spoken much of colour in the daylight, the red of iron, the black of coal, the yellow of calcite, but some rocks hold a secret colour that can only be seen in the dark. We enter the realm of fluorescence. Imagine standing in a dark room, holding a grey, unassuming rock from Franklin, New Jersey. It looks like a piece of gravel from a driveway. Now turn on an ultraviolet lamp, a black light. Instantly the rock transforms. It glows with a neon intensity that seems impossible. Bright electric greens, vivid reds, vibrant oranges. The mineral willemite glows green, calcite glows red. This is the electrons within the atoms of the rock absorbing the invisible ultraviolet energy and releasing it as visible light. It is a cold light, a ghostly radiance that comes from within the stone. It feels like magic seeing a dull stone ignite with such colour. It reminds us that there is more to the world than what our eyes can see in the sunlight. There are hidden spectrums, hidden energies, and the rocks are waiting for the right light to reveal their true, vibrant nature. Finally, there is a light that comes not from radiation, but from friction. This is the phenomenon of triboluminescence. It is the spark of the earth itself. Visualize sitting in a pitch-black room with two smooth quartz pebbles in your hands. The silence is absolute. You bring the stones together, rubbing them hard or striking them against one another. In the moment of impact, there is a sound, a sharp clack of stone on stone, and simultaneously, a flash of orange-yellow light illuminates the darkness. It is a fleeting spark, gone as soon as it appears. This light is born from the breaking of chemical bonds in the crystal lattice, releasing energy as photons. It smells faintly of ozone or burning. It is a primitive, visceral experience, creating fire from cold stone. It feels like summoning a spirit from the rock. The quartz is cold, but the light is the colour of heat. It is a reminder that the earth is full of potential energy, waiting for the pressure, the friction, the contact to release its spark. It is a tiny, handheld lightning storm, a flash of brilliance born from the resistance of the stone. From that fleeting, visible spark of triboluminescence, born of friction and resistance, we descend deeper into the invisible, rhythmic heartbeat of the stone. The quartz crystal, so cool and still in your hand, holds a potential for energy that goes beyond the flash of a spark. This is the phenomenon of piezoelectricity. It is a word that whispers of pressure and electricity. Imagine a perfect, clear quartz crystal. Inside, its atoms are arranged in a precise hexagonal spiral. When you apply mechanical stress to this crystal, when you squeeze it or press it, the structure shifts ever so slightly. This shift forces the positive and negative charges within the crystal to separate, creating a tiny rhythmic pulse of electrical voltage. It is the rock transforming touch into power. Think of the quartz watch that might be resting on a nightstand. Inside that watch is a tiny tuning fork made of quartz. A battery sends electricity into it, causing it to vibrate, to breathe, at exactly 32,668 times per second. This vibration is the heartbeat of modern timekeeping. We have taught the stone to count the seconds for us. It is a profound realization that the steady, reliable marching of time in our civilization is governed by the vibrating soul of a crystal. The earth is not silent. It is humming, vibrating, and keeping time in a frequency too high for our ears, but perfect for the rhythm of the universe. When you rest your head on a pillow, imagine the quartz grains in the deep earth, squeezed by the weight of mountains, humming their own silent electric song in the dark. From the hard, vibrating precision of quartz, we drift to a mineral of profound softness and clarity, a stone named after the moon itself, selenite. This is a form of gypsum, the same mineral that makes up the white sands and the alabaster statues, but here it grows in transparent swords of monumental size. Visualize the Cave of the Crystals in Nacre, Mexico. It is a sweltering, humid womb deep within the earth. Here, giant beams of selenite, some as thick as tree trunks, and as long as a school bus, crisscross the cavern darkness. They are not grey or brown. They're absolutely clear, like frozen water or solid light. Because they grew submerged in mineral-rich water that remained at a stable, hot temperature for 500,000 years, they had no reason to stop growing. There is a divine stillness in selenite. It is soft. You could scratch it with a fingernail. It represents the fragility of perfection. If you were to touch one of these giant crystals, it would feel warm and slick with condensation. It looks like a bridge of ice, but it is warm to the touch. Selenite is said to inhabit the space between matter and light. Holding a smaller piece in your hand, you can see through it, but the world on the other side looks dreamy and whitewashed. It acts as a natural fibre optic, channeling light along its length. It is the Earth's way of solidifying a moonbeam, capturing the essence of a pale white glow and giving it weight and form. Closely related to these giant beams is a fibrous variety of the same mineral, known as satin spar. While selenite is a window, satin spar is a veil of silk. Imagine a stone that looks like a spool of white thread that has been petrified. It is composed of thousands of hair-thin crystals packed tightly together in parallel lines. When you turn a polished piece of satin spar in the light, a band of white light glides across the surface. This is the cat's eye effect, or chatoyancy. It is a mesmerizing, fluid motion on a solid object. The light is catching on the internal fibers, reflecting off the microscopic channels within the stone. It feels incredibly smooth, almost oily or soapy because of its softness. Rubbing a thumb over a worry stone made of satin spar is a tactile meditation. It feels more like solidified fabric than rock. It invites a gentle touch. It reminds us that geology is not always rough, jagged, and hard. It can be silky, fibrous, and yielding. It mimics the textures of the living world, the sheen of a muscle, the gloss of hair, yet it is born entirely from the evaporation of ancient salty seas. It is the memory of water, woven into a stone tapestry that plays with the light. From the soft white memory of earthly seas, we turn our eyes upward to the dark ocean of space to witness a violent marriage between the earth and the heavens. We speak of tektites. These are not meteorites themselves, but the splash of the earth. Visualize a massive asteroid striking the planet millions of years ago. The energy of the impact is so intense that it instantly melts the terrestrial rock at the impact site, vaporizing it and throwing it high into the upper atmosphere, sometimes even into space. There, in the vacuum and the cold, This molten rock cools instantly and falls back to Earth as rain. But it is not water rain, it is glass rain. These droplets harden into aerodynamic shapes, teardrops, dumbbells, buttons, as they spin through the air. One of the most beautiful varieties is moldavite, found in the fields of the Czech Republic. Picture a piece of green bottle glass stone. It is wrinkled and textured like the skin of an avocado or a dried prune. This texture comes from the acid in the soil etching the glass over millions of years. Holding a piece of moldavite, you are holding a piece of the earth that has touched space. It has flown higher than any bird, travelled faster than a bullet, and returned home transformed. It is a deep, forest green, translucent and bubbly. It vibrates with the energy of that ancient impact, a frozen echo of the moment when the ground learned to fly. Sometimes, the rock that falls from the sky is not earthborn glass, but a visitor from the core of a shattered planet. These are the iron meteorites. Imagine a rock that is incredibly heavy for its size, dense and unyielding. It is not made of stone, but of solid iron and nickel metal. The outside is smooth and dark, melted by the heat of entry into our atmosphere, creating a fusion crust that looks like dark chocolate or gunmetal. But the true secret lies inside. If you slice this meteorite open and etch the surface with a mild acid, a hidden geometric pattern emerges. This is the Widmanstätten pattern. Visualize a cross-hatching of silver lines, interlocking triangles and parallelograms that shimmer as you tilt the metal. This pattern cannot be faked. It cannot be created in a lab. It forms only when molten iron and nickel cool down incredibly slowly, over millions of years, in the vacuum of space, deep inside the core of a planetary body. The crystals grow large because they have eons to arrange themselves. When you run your finger over these etched lines, you're touching a clock that measured time in eras, not hours. It is the signature of the cosmos, a celestial fingerprint that proves this metal was once the heart of a world that no longer exists, wandering the dark until it found a resting place in your hand. Even rarer and more beautiful than the solid iron are the stones where metal and gem mix. These are the pallasites. Imagine a sponge made of bright silver iron, but instead of being filled with air, the holes in the sponge are filled with golden green crystals of olivine, the peridot we spoke of earlier. This is the most stunning material in the solar system. It is a stained glass window made by the universe. These stones come from the boundary layer of an asteroid, the twilight zone between the molten metal core and the rocky mantle. When sliced and polished, a pallasite looks like a celestial mosaic. The light shines through the green gems, while the silver metal frames them in a rigid metallic web. Visualizing this stone, you see the suspension of the yellow-green drops in a silver sea. It represents a perfect equilibrium, a moment of mixing frozen in time. It is heavy, cold, and breathtaking. It reminds us that deep inside the planets, there are landscapes of beauty we can scarcely imagine. Oceans of metal studded with islands of gem, hidden forever in the dark, unless a lucky collision brings a piece of that hidden art crashing down to us. We look up from these fallen fragments to the great silver companion that orbits our world, the Moon. We often think of it as a distant light, but it is a geological body, a child of the Earth. The bright white highlands of the Moon, which we see glowing in the night sky, are made of a rock called anorthosite. Visualize a rock that is almost entirely pure white feldspar. On Earth, this rock is rare, found in old mountain roots. On the Moon, it is the crust. It formed billions of years ago when the entire Moon was a magma ocean. As the magma cooled, these light white crystals floated to the top like foam on a cappuccino, forming a bright reflective skin. This is why the Moon shines. It is a giant mirror made of floating crystals. Imagine standing on the lunar surface, surrounded by this stark white desolation. The dust is sharp and abrasive, never smoothed by wind or water. It is a landscape of absolute stillness, preserved in a vacuum. The whiteness of the anorthosite reflects the sun, acting as a beacon in the dark night. It connects us to the early, violent history of the solar system, a time when worlds were molten and crusts were just beginning to form, floating like white rafts on a sea of fire. The moon does not just sit there, it pulls. We know it pulls the oceans, creating the tides that wash the beaches, but few realise that it also pulls the rock. This is the phenomenon of earth tides. We think of the ground beneath us as solid and immovable, but it is elastic. It stretches. As the moon passes overhead, the solid crust of the earth bulges upward, pulled by gravity. The ground you're standing on right now rises and falls by about 12 inches, 30 centimetres, twice every day. Visualize the entire continent of North America, or Europe, or Africa, gently rising and falling like the chest of a sleeping giant. You do not feel it because everything around you rises and falls with it. The buildings, the lakes, the mountains, they all ride this slow wave of stone. It is a reminder that solid is a relative term. On the scale of the solar system, the Earth is a rubber ball, constantly kneaded and massaged by the gravity of its companion. This constant flexing generates a tiny amount of heat deep inside the planet, a friction of rock against rock, keeping the heart of the world warm. It creates a rhythm of existence, a breathing motion that spans the entire globe, uniting the land and the sea in a celestial dance. The land also rises and falls on a much slower, longer timescale, reacting not to the moon, but to the weight of ice. This is a solstice, or glacial rebound. Imagine the Earth's crust not as a hard shell, but as a raft floating on the thick molasses-like mantle below. 20,000 years ago, during the last ice age, massive sheets of ice, 2 miles thick, sat on top of Canada, Scandinavia, and Scotland. This immense weight pushed the crust down, sinking it hundreds of feet into the mantle, just as a mattress sinks when you sit on it. Now, the ice is gone. The weight has been lifted, but the Earth is slow. It is still springing back. Visualize the land of Scandinavia rising, millimetre by millimetre, year by year. Harbours that were once deep are now shallow. Beaches that were once at the water's edge are now high in the hills. It is the slow-motion sigh of the planet, the crust stretching out after carrying a heavy burden for so long. It tells us that the Earth has memory. It remembers the weight of the ice, and it is still recovering, still moving toward equilibrium. It is a comforting thought that after the pressure is gone, there is a recovery, a slow, patient rising back to where we belong. Finally, we drift from the rising land down to the edge of the continent, to the shallow, sunlit ledge known as the continental shelf. This is the submerged rim of the land, a terrace that extends out into the ocean before the true deep begins. Visualize a vast underwater plain. The water here is shallow, perhaps only a few hundred feet deep. Sunlight filters down through the turquoise blue, dappling the sandy bottom with dancing patterns of light. This is the most vibrant part of the ocean, the nursery of the seas. The shelf is essentially a drowned extension of the continent. It is covered in soft sands and sediments washed down from the rivers. It is a gentle, sloping landscape, a bridge between the dry land and the deep abyss. In the past, during the ice ages when sea levels were lower, this shelf was dry land. Mammoths walked where fish now swim. Imagine the peace of this underwater plateau. The currents are gentle sweeps of water. The sand is rippled by the waves above. It is a place of light and life, a shallow threshold that cradles the continents, buffering them against the vast, dark power of the open ocean. It is the familiar front porch of our land masses, submerged in a warm blue dream, waiting for the cycle of the ages to perhaps one day lift it into the sun again. At the edge of that sunlit continental shelf, where the sand is rippled by the gentle play of the tides, and the water is a familiar turquoise, the ground suddenly falls away. We have reached the precipice of the deep, the beginning of the continental slope. Here, the gentle incline transforms into a steep descent, plunging down into the true abyss. It is on this dark, sloping face that we encounter the phenomenon of the submarine canyon. Visualize a canyon as grand and jagged as the Grand Canyon, with towering walls of rock and winding serpentine paths, but submerged entirely in the crushing darkness of the ocean. These are not carved by rivers of rain, but by rivers of sand and silt known as turbidity currents. Imagine a massive underwater avalanche, a dense cloud of sediment-laden water that is heavier than the clear ocean around it. It flows down the slope like a liquid landslide, moving at the speed of a freight train, tearing at the sea floor, scouring out the bedrock. In the silence of the deep, this is a moment of violent creation, a rushing, scouring force that carves V-shaped valleys into the edge of the continent. Yet, when the current settles, the canyon returns to a profound stillness, a hidden gorge where deep-sea creatures glide silently between cliffs that have never felt the warmth of the sun, monuments to the power of gravity acting in the dark. At the bottom of these slopes, where the energy of the avalanche finally dissipates, the sediment fans out across the vast flat floor of the ocean. Here, in the most remote and quiet places of the planet, a strange and slow geological harvest is taking place. We drift over the sediment to find the manganese nodules. Picture a vast field of black potato-sized stones scattered across the soft beige mud of the abyssal plain. They sit there, separated by inches, stretching out for thousands of miles like cobblestones on a forgotten road. These are not rocks that fell from above. They are rocks that grew from the water. Over millions of years, metals dissolved in the seawater, manganese, iron, nickel, cobalt, have slowly precipitated out, latching onto a tiny nucleus, perhaps a shark's tooth or a fragment of shell. Layer by atomic layer, the metal builds up, forming concentric rings around the centre. The growth is unimaginably slow, a mere few millimetres every million years. To hold one of these nodules is to hold a condensed history of the ocean's chemistry. They are heavy, dense and metallic, resting in the eternal cold, a treasure trove of rare elements that the ocean has patiently concentrated in the silence of the deep, waiting in the dark like sleeping seeds of metal. Leaving the silent fields of nodules, we travel across the plain until the ground begins to rise again. We're approaching the spine of the world, the mid-ocean ridge. This is the longest mountain range on Earth, wrapping around the globe like the stitching on a baseball, yet it is almost entirely hidden beneath the waves. Visualize a landscape of jagged black volcanic peaks, rent down the centre by a massive rift valley. This is the birthplace of the ocean floor. Here the tectonic plates are pulling apart, ripping the crust open. As the crack widens, the hot molten mantle from below rises up to fill the gap. It is a place of constant renewal. The heat here is palpable, a stark contrast to the freezing water just a few meters away. You can feel the shudder of the earth as it cracks, the seismic swarms of tiny earthquakes that announce the birth of new stone. It is a wound that never heals, but instead creates new skin for the planet, pushing the old seafloor aside to make room for the new. It is the engine of geology, a factory of crust operating in the permanent night, driving the movement of the continents thousands of miles away. As the molten rock rises from the ridge and meets the crushing weight of the cold seawater, it does not flow like a river. It squeezes out in a specific bulbous shape. This is pillow lava. Imagine a tube of toothpaste being squeezed out onto a cold table. The outer skin freezes instantly into a black glassy crust, but the inside remains red hot and fluid. The pressure builds until the skin bursts, and a new bulb of lava oozes out, freezing again. This process repeats, piling up lobes of rock that look like black stone pillows stacked one on top of the other. Visualize a mountainside made of these rounded, blobbish forms. They are bulbous and organic looking, like a pile of giant, sleeping stony creatures. When you see this rock high up in a mountain range on land, you know instantly that this ground was once deep underwater. It is the signature of the submarine volcano. The texture is glassy and fractured, often with a hollow sound if struck. It represents the battle between fire and water, a battle where the fire is instantly tamed and frozen into these soft, billowing shapes of solid rock. In the cracks and fissures of this new volcanic rock, seawater seeps down, deep into the hot crust. It is heated by the magma below, dissolving minerals from the rock, and then shoots back up to the surface in a jet of superheated fluid. These are the hydrothermal vents, or black smokers. Visualize a chimney made of sulfur and iron, rising 30 feet from the sea floor, spewing a cloud of dark, mineral-rich water that looks like thick black smoke. The water is hot enough to melt lead, yet the immense pressure of the ocean keeps it from boiling. It shimmers with heat. Around these vents, in the pitch black, life thrives. Giant tube worms with red plumes, blind crabs, creatures that rely not on the sun, but on the chemical energy of the Earth itself. The chimneys themselves are geological wonders, growing rapidly as the minerals in the hot water hit the cold ocean and crystallize instantly. They are fragile towering spires of pyrite and anhydrite, gold and white in the lights of a submersible distinct islands of heat and energy in the cold wasteland. They remind us that the Earth is alive with heat, breathing out the minerals that sustain a hidden, alien ecosystem. The new crust created at the ridges must eventually go somewhere. It travels across the ocean basin over millions of years, cooling and becoming denser until it crashes into another plate. Here, it bends and dives, beginning its long journey back into the mantle. This is the subduction zone, marked by the deep trenches. Drift over the edge of this abyss. This is the deepest the Earth goes. Visualize the Mariana Trench, a scar in the crust shaped like a crescent moon. The ocean floor here curves gently downward, then plunges. The scale is impossible to grasp. You could hide Mount Everest in this trench and still have miles of water above the peak. Down here, the pressure is a crushing force, thousands of times greater than at the surface. The rock of the ocean floor, old and cold, laden with the sediment of eons, is sliding smoothly beneath the lighter continental rock. It creates a massive friction, a locking and unlocking that generates the world's most powerful earthquakes. It is the recycling center of the planet, where the history recorded in the stone is swallowed up, melted down, and returned to the primal soup of the mantle to be born again. As the oceanic plate dives deeper, the heat and friction cause water trapped in the rock to be released. This water rises into the mantle above, lowering its melting point and creating blobs of magma. This magma punches its way to the surface, creating a curved chain of volcanoes known as an island arc. Think of the Aleutian Islands or the Japanese archipelago. These are the children of the trench. Visualize a line of conical peaks rising from the sea, their summits capped with snow, their bases lost in the dark water. They are violent and beautiful, often smoking, constantly building themselves up with layers of ash and lava. They form a perfect arc, mirroring the curve of the trench deep below water. To stand on one of these islands is to stand on a precarious platform, a pile of fire-born rock that is constantly being pushed upward by the subduction factory below. It is a landscape of steep slopes and jagged coastlines, where the connection between the destruction of the old crust and the creation of new land is immediate and visible. Sometimes, a volcano forms not at the edge of a plate, but in the middle of one, fed by a stationary plume of heat rising from deep within the mantle. This is a hot spot. Imagine a blowtorch fixed in one spot pointing upward. Now, imagine a sheet of paper, the tectonic plate, sliding slowly over that flame. Where the flame burns through, a volcano forms. But as the plate keeps moving, that volcano is carried away from the heat source, and the fire dies. A new volcano forms behind it, then another and another. This creates a linear chain of islands like Hawaii. Visualize the big island, massive and growing, glowing with active lava flows. Then, look to the northwest, to the older islands. They are smaller, greener, more eroded. The farther you go, the smaller they get. It is a conveyor belt of island creation. The hotspot is a window into the deep mantle, a fixed point in a moving world. It tells the story of the plate's motion, a trail of stone breadcrumbs left across the ocean to show us where we have been. As these volcanic islands drift further away from the hotspot, they cool and sink. The ocean waves attack their shores, eroding the rock, planing the top off until the island is flat. Eventually the island sinks completely below the waves. These drowned, flat-topped mountains are called guyos. Visualize a mountain underwater. Its sides are steep, but its top is perfectly flat like a table. It sits in the dark, thousands of feet below the surface. Once this flat top was a beach. It felt the sun. It heard the cries of seabirds. Now it is a silent plateau in the abyss, covered in soft marine snow. Guyots are the ghosts of islands. They are evidence that the ocean floor is sinking as it cools. They stand as silent, flat-topped monuments to the erosive power of the waves and the relentless subsidence of the crust. To find a Gaio is to find a lost world, a sunken kingdom that once broke the surface, but has now returned to the deep. Before the island sinks completely, if the water is warm and life is plentiful, a beautiful transformation occurs. Coral reefs grow in the shallow water around the volcanic rim. As the heavy volcano slowly sinks, the coral grows upward, keeping pace with the rising water, desperate to stay in the sunlight. This creates an atoll. Visualize a perfect ring of turquoise water in the middle of the dark blue ocean. The central island is gone, swallowed by the sea. All that remains is the circular barrier reef, a thin ribbon of white sand and green palms enclosing a calm, shallow lagoon. It is a ghost outline of the volcano that once was. The geology here is hidden. The volcanic foundation is buried deep beneath the limestone of the coral. The atoll is a collaboration between stone and life, a balancing act where tiny polyps build a cathedral of calcium to resist the sinking earth. It feels like a paradise, a quiet circle of calm water protected from the ocean's fury, a tomb for a mountain that has become a cradle for a reef. From the quiet, sunken history of the atoll, we move to a violent event that brings the ocean's power crashing onto the land. We speak of the tsunami stone. In coastal landscapes, far above the high tide line, one sometimes finds massive boulders, weighing hundreds of tons, sitting alone in a field or a forest. They are often covered in marine barnacles or made of coral limestone. These rocks were not moved by glaciers or rivers. They were thrown there by the sea. Visualize the moment. A massive earthquake shifts the ocean floor, displacing a colossal volume of water. A wave, silent and long, travels across the ocean. When it hits the shallow coast, it rears up, becoming a wall of water. It grabs these immense boulders from the reef or the shore and hurls them inland like pebbles. When the water recedes, the rocks remain stranded in the grass. These erratic boulders are geological warnings. They sit quietly in the landscape, moss growing on their sides, whispering of the day when the ocean overstepped its bounds. They are heavy, immovable memories of the wave marking the high water line of history, reminding us that the boundary between land and sea is never truly fixed. Just as the ocean currents carry massive stones to foreign shores, the rivers of fire deep within the earth also carry passengers from distant lands. Embedded within the cooling granite of a cliff face, you might sometimes spot a dark, jagged shape that looks completely out of place. This is a xenolith. The word means foreign rock. Visualize a chamber of pink molten magma rising slowly through the crust millions of years ago. As it ascends, it rips a chunk of black rock from the cavern wall, a piece of the deep mantle or the lower crust. This fragment falls into the melt like a crouton dropping into a thick soup. But the magma cools before it can fully melt the intruder. The result is a rock within a rock, a dark island trapped forever in a sea of lighter stone. When you touch a xenolith, you're touching a traveller that didn't make it all the way home. It stands out, a stark contrast in colour and texture, often surrounded by a reaction rim, a thin halo where the two rocks try to interact chemically. These stones are messengers from the inaccessible depths. We cannot drill down to the mantle, but the earth brings pieces of it up to us, encased in granite envelopes. They remind us that the ground is not a single uniform block, but a chaotic mixture of layers, where the deep past is sometimes caught and held suspended in the younger rock, a permanent guest in a stone home. Sometimes the magma does not trap a foreigner, but instead begins to dream in circles. In very rare and special conditions, when the cooling is undisturbed and the chemistry is just right, granite does not form a speckled grain but perfectly concentric spheres. This is orbicular granite. Imagine standing before a rock face that looks like it is covered in bullseyes or petrified eyes. Each orb is made of alternating layers of dark and light minerals, black mica and white feldspar, radiating outward from a central seed. They cluster together, pressing against one another, creating a pattern that is dizzying and hypnotic. It looks organic, like cells under a microscope or the rings of a tree, yet it is born of intense heat. These orbs grew in the magma chamber, suspended in the liquid, adding layer after layer as they bobbed in the currents. To find an outcrop of orbicular granite is to find one of nature's rarest galleries. The geometry draws the eye in. It feels rhythmic, a visual pulsation in the stone. It suggests that even in the chaotic melting pot of a volcano, there is a desire for symmetry, a hidden pulse that seeks to organize the minerals into perfect rounding embraces. From the circles formed in fire, we turn to the curves painted by water. In the porous vastness of sandstone cliffs, groundwater rich in iron sometimes seeps through the grain. It moves in pulses, precipitating iron oxide in rhythmic repeating bands. These are the Liesegang rings. Visualize a slab of sandstone that looks like wood grain, or a topographical map, or a sunset frozen in rock. Swirls of deep rust red, burnt orange, and pale cream dance across the surface. These are not sedimentary layers laid down by gravity. They are chemical fronts that migrated through the solid rock. The pattern is intricate and unpredictable, ignoring the straight lines of the original bedding. Run your fingers over the rough sandy surface. The iron-rich bands might be slightly raised, harder than the lighter stone between them. It looks like the ripples of a stone thrown into a pond but captured in 3 dimensions. It is nature's tie-dye, a chemical art project that takes place in the absolute dark of the underground aquifer. When revealed by erosion, these rings turn a simple beige cliff into a mural of warm, earthy curves, soothing the eye with their continuous flowing organic geometry. The iron that paints the sandstone in abstract swirls can also create distinct representational art. We drift now to the desert silts to find landscape jasper. This stone is a master of illusion. When you slice a piece of this jasper, you do not see a random pattern. You see a picture. Visualize a polished cabochon that looks exactly like a sepia-toned photograph of a desert horizon. You see rolling hills of brown, a distant mountain range of blue-grey, and perhaps a cloudy sky of cream and charcoal. There are even distinct trees and bushes dotting the foreground. But no artist painted this. These images are created by the uneven diffusion of the mineral oxides, iron and manganese, through the silica mud as it turned to stone. The sky is pure quartz. The hills are iron-stained. Holding a piece of landscape jasper is like holding a window into a dream world. It is a miniature scenery that exists only inside that specific rock. It invites you to wander with your eyes, to hike the little brown ridges and rest in the valleys of the stone. It blurs the line between the landscape we walk on and the material the landscape is made of, suggesting that the earth carries a memory of its own beauty deep inside its very substance. If landscape jasper captures the desert, then this next stone captures the damp green silence of the forest floor. We speak of moss agate. This is a clear or milky white chalcedony that appears to be filled with delicate green fronds of moss floating in a dense fog. Look closely into the depth of the stone. You see branching filaments, rich forest greens, dark teals, and sometimes hints of red. It looks for all the world like vegetable matter, a piece of the swamp trapped in ice. But, like the dendrites we spoke of earlier, this is a mineral trick. These are not plants. They are inclusions of greenhorn blende or chlorite that grew in fern-like patterns within the silica gel. Despite knowing it is mineral, the sensation of the stone is purely botanical. It feels cooling, refreshing, like a breath of fresh air. It is a gardener's stone, evoking the feeling of growth and tangled vegetation. Holding a piece of moss agate is like holding a permanent spring morning. It offers a connection to the green world, preserved in a medium that will never wilt, a frozen terrarium that fits in the palm of your hand. From the cool, green silence of the agate, we shift to a stone that watches us with a warm golden gaze. This is the phenomenon of chatoyancy, most famously seen in tiger's eye. This stone begins its life as a blue mineral called crocodylite, which is made of fine, fibrous threads. Over millions of years, quartz crystals replace the fibres, and iron rusts the blue into a rich golden brown. Visualize a polished stone that looks like a piece of silk made of gold and honey. As you tilt it back and forth in the light, a bright band of light glides across the surface, opening and closing like the pupil of a cat. This moving line is light reflecting off the internal, parallel fibres. The colours are warm and comforting, bands of chocolate, amber and gold. It feels smooth and glassy, yet it has a visual texture that looks like fur or wood. The movement of the light gives the stone a sense of awareness, a watchful presence. It acts as a talisman of protection. The steady, sliding gleam of the eye is hypnotic, encouraging a slow, rhythmic breathing as you rock the stone in the light, watching the band travel back and forth, in a silent, golden metronome. While tiger's eye captures the golden earth, another stone captures the glittering essence of the star that warms it. We turn to sunstone. This is a feldspar mineral, usually a warm orange or peach colour. But what makes it special is the schiller, or aventurescence. Visualize a gemstone that seems to be filled with millions of tiny floating sequins. These are microscopic platelets of copper or hematite suspended inside the crystal. When the light hits them, they flash with a metallic, fiery brilliance. It looks like the sun reflecting off the ocean at dawn, a field of sparkles contained within a solid object. The stone glows with an internal warmth. It is joyful and bright. In some varieties, the copper is so dense the stone looks like solid metal. In others, it is a transparent wash of champagne colour with just a hint of glitter. Holding sunstone is like holding a solidified piece of late afternoon heat. It radiates a sense of energy and abundance, a mineral reminder of the symbiotic relationship between the planet and the star that gives it life. The balance to the sun is, of course, the moon. And the Earth has a stone for this as well, moonstone. This is the sister to sunstone, another feldspar, but its mood is entirely different. Instead of glitter, it possesses a dulurescence, a soft, billowing blue light that floats just below the surface. Imagine a smooth white pebble found on a beach at twilight. As you move it, a ghostly blue sheen washes over the face of the stone, like moonlight parting the clouds. This effect is caused by the light scattering between microscopic layers of two different types of feldspar, orthoclase and albite. They intergrow in thin, alternating lamellae. The light is not sharp, it is diffuse, dreamy, and liquid. It looks like water trapped inside the rock. The stone feels cool, feminine, and mysterious. It invites you to soften your gaze, to look past the surface. It is the stone of intuition and the subconscious, glowing with a light that seems to come from a world of dreams. It is a piece of the night sky brought down to earth, a quiet blue whisper to balance the golden shout of the sunstone. From the celestial lights of feldspar, we descend into the deep, throbbing veins of the Andes Mountains to find the stone of the heart, rhodochrosite. This is a manganese carbonate mineral that forms in hydrothermal veins, often growing in layers like a stalactite. Visualize a slice of this stone. It is an explosion of pink. From the palest baby pink to a deep raspberry red, it is banded with zigzagging lines of white, creating a pattern that looks like bacon or the petals of a rose viewed from above. It is often called the Inca rose. The texture is soft and smooth. The colour is incredibly vivid, almost looking like candy. It is a warm, physical stone. While blue stones feel cool and intellectual, rhodochrosite feels emotional and tender. It represents the pulse of the blood and the warmth of the flesh. The white bands break up the intensity of the red, creating a soothing rhythm. It is a stone that feels like a hug, a geological manifestation of compassion and love, grown slowly in the dark veins of the mountains, layer by rosy layer. Finally, we turn to the rich velvet green of malachite. This is the stone of copper, formed where copper ores are weathered by the rain and air. It does not form crystals you can see with the naked eye. Instead, it grows in botryoidal masses, bumpy, rounded shapes that look like bubbles. When you slice through these bubbles, you reveal a mesmerizing pattern of concentric rings and swirling bands. Visualize the deepest forest green you can imagine, alternating with lighter, bright grass greens. The patterns look like the grain of wood, or the eyes of a peacock feather, or the topography of a green valley. The stone is heavy, dense with metal. It is opaque, absorbing the light rather than reflecting it. It feels solid and grounding. Malachite was used as a pigment in ancient paintings. The green of the Renaissance trees is often crushed malachite. To look at it is to lose yourself in a labyrinth of green curves. It is the colour of nature's abundance, frozen in stone. It feels like the deep, cool shade of an ancient oak tree, a place of rest and shelter. The swirling lines lead the eye inward, never ending, a perpetual motion of growth captured in the heavy, silent carbonate. It is the earth wrapping itself in a blanket of emerald, soothing and deep. And so, having held the green comfort of the malachite, and having witnessed the fire of the diamond and the silence of the sediment, we arrive at the final, overarching truth of our journey. This is not a single stone, nor a specific mountain, but the realization of the great cycle itself. We call it the rock cycle, but in the dream of deep time, it is simply the Earth's way of breathing. Pause for a moment and try to perceive the world not as it is today, but as a fluid, moving entity. If you could watch the planet with the eyes of the universe, speeding up the millions of years into mere seconds, the illusion of solidity would vanish. You would see that the ground beneath you is not a platform but a river. We have seen that the fire cools to become granite. The rain wears the granite down to sand. The river carries the sand to the sea. The weight of the ocean turns the sand to stone. The heat of the core melts the stone back into fire. There is no beginning, and there is no end. There is only the flow. This means that every pebble you have ever touched is just a momentary pause in a never-ending transformation. The molecules in the mountains of the Himalayas were once the shells of creatures in a prehistoric sea. The sand in the desert was once the peak of a jagged Alp. And most profound of all, this cycle includes you. The calcium in your bones, the iron in your blood, the carbon in your breath. All of it was once rock, mined from the crust by the plants and the water, lent to you for a brief, shining moment of consciousness. You're not separate from the earth. You are the earth, animated. You're a walking, breathing piece of geology, a rearrangement of the ancient dust that has swirled through the mantle and the sky for 4 billion years. To understand geology is to understand that you are part of this slow, majestic dance of matter, rising from the earth and eventually returning to it, caught in the beautiful, eternal loop of renewal. Now, the journey is complete. The vast museum of the earth is closing its doors for the night. The lights are dimming in the Hall of Crystals. The roar of the volcano is fading into a whisper. The rush of the river is slowing to a gentle trickle. It is time to let the stones fall from your hands. Let the images of the red canyons and the blue glaciers dissolve into the soft velvet darkness behind your eyes. You do not need to remember the names. You do not need to recall the processes. They are all recorded in the library of the ground, safe and permanent. You can let go. Feel the gravity of the planet reaching up to claim you, not to pull you down, but to anchor you. This force that holds the mountains in place, that keeps the moon in its orbit, now holds you in your bed. It is a heavy, warm, affectionate weight. Visualize yourself sinking slowly into the comfort of this gravity. You're drifting down through the layers of the night, past the noise of the surface, past the worries of the day, sinking deeper into the quiet, cool stillness of the bedrock. It is so silent here. The earth is stable. It has endured for eons, and it will endure for eons more. You can rest your weight upon it without fear. It will carry you through the night. Your breathing is slow, matching the rhythmic tide of the magma deep below, in and out, rising and falling. The world is turning slowly in the dark, a cradle of stone and water rocking you into the void. The fire is banked, the wind is still, the ocean is calm, everything is in its place, everything is at peace, and now 101 wonders are resting with you. Sleep now, good night.